And we are live. Hey, everybody, good to see you. Glad you could make it for this epic showdown. It's going to be good. Between Wesley and Roger, Gravity versus RDD. Um, it's good to be here. Good to see you guys. Glad you could all make it. Thank you guys for choosing this platform to debate. I hope I'll be a good enough moderator for you guys. I don't know if you guys want to do intros, not that it's needed, but before we do the actual debate, say who you are.
Yeah, I don't mind. My name's Wes. I have only been in this flat Earth arena for maybe 2 years. I am an engineer, electrical engineer. I graduated from school with a bachelor's of science, and I love doing these debates. Well, I love just being part of the group anyway, just because I learn about science. I learn about new things that I hadn't considered before, and it also helps sharpen my explaining skills for what I do. So I love the opportunity. So thanks for having me.
Awesome, awesome. And then Roger.
No, yes, my name is Roger Ledwell. I've been in this arena for probably close to a decade. I've heard every kind of argument, but I do like the argument. It sharpens everybody's skills and keeps everybody aware of every bit of the topic, and I like keeping it on point.
Yep.
That's about it.
Awesome, awesome. I'm again very blessed to have you guys here. Thank you very much. I'm sure we're going to have a great discussion. It's not really going to need me.
Yep.
I'll just keep the time actually. So Wesley's going to start off with his 5 minute opening, and then Roger will do so too, and then we'll hop into 5 minute rebuttals and then open discussion. But
Yeah.
so Wesley, if you're ready, you can do so.
Yeah. I'm sorry. I have to upload this into here. I guess that's the easiest way. So give me
Yeah,
1 second.
Das ist gut, ja.
Am I glitching?
No, no, no. No, you're
Fine.
fine.
Yeah. I'm gonna just present my desktop. Share screen.
Just want to find out, is your surname German?
It's German French, so they call it the Alsace area. So yes.
Okay, that's okay.
All right. So I think I should be able to share this and keep me on task. If I'm off time, just let me know. But I'm going to present this. Slideshow start from current slide. Okay. I'm bad at tech, even though I'm an engineer. I'm terrible at tech, so I'm not afraid to admit that. So, yeah, thanks, Flatzoid, for having this debate. Thank you to Roger for challenging me and sticking or creating this topic. Love to talk about this, and yeah, hopefully we have a good, lighthearted discussion. Always like sharing ideas and hearing about ideas. So, we're going to be talking about my position is gravity is real and measurable, and the other side would be RDD, relative density displacement or disequilibrium, which Roger will present. So I'm going to start just with my side first. And first, I want to talk about why science is important, because we'll bring this discussion into clarity as we go through it. So science is used to describe natural phenomenon and explain why and how nature occurs and predict what will happen next. Those are the three. Hold on a second. I'm getting a backbeat here.
It sounds fun on me on my side there.
Yeah, no, I was just getting music in from another stream. So keep going here from current slide. So that in science, we come up with formulas that we can turn observations into calculations and then test claims about our reality. So today we'll be testing gravity, we'll be testing RDD, and then from that we can come up with formulas and calculations to predict what will happen in the future. And the reason why that's important is people use this to bring formulas to designs for buildings, bridges, aircraft, obviously. Build satellites, launch them into space, if you believe that, or planes. You can just go with that. Ideas are great. We all have good ideas. We all have terrible ideas. I remember a good friend of mine came up with this idea of a boat, car, copter kind of thing I see here on the right. I'll play it for you, but it wasn't a very good idea. We tried it for a little bit and it kind of fell apart. So we test these ideas, and if they fail like that, then they're probably not good ideas, or we have to change something about it to do good. So what we're asking today is, which model, gravity or RDD, can be used to calculate, predict, and enable us to build new technology or build infrastructure? So let's talk about the universal law of gravitation that was brought up here between Einstein and Newton. Newton brought up the universal law of gravitation, and Einstein refined it to the theory of relativity that we now know of today's. But what's really important in here, and I'm just going to highlight the text, the third line or fourth line down. Einstein says that the theory of relativity is not a theory of space alone or time alone, but of space and time together. In the limit of weak gravitational fields, which is what we have here on Earth, it leads to the Newtonian theory. So gravity is the natural measurable, we measure it, acceleration of masses toward each other. And I'm going to show those experiments in a second here, caused by gravitational fields. Newton's laws calculate motion accurately, here, not only here on Earth, but also the orbits of the planets and comets. So these equations on the left are all from Newton, and they were verified through Einstein in non-relativistic speeds or gravities. And so, on the left here, these are all fancy, variables or fancy letters, but it's pretty simple. The one on the left here, force, is equal to the gravitational constant, which is constant for all things. And then you have two masses. So on Earth, it would be the mass of Earth and then the mass of, let's say, us, or the mass of the falling object. And it's divided by the distance between the center of those objects squared. So what gravity is, you may not like the word gravity, and that's fine, but it's the word we came up for the acceleration between two objects. So if we don't want to use that word, that's fine with me. But it is dependent upon the two masses and the distance between the two. And we'll go over a couple slides that prove that.
30 seconds left.
How many?
30 seconds left. Okay.
I'll go through this quick, but these are the four experimental proofs. Cavendish, this is a picture of it on the right here. Then vacuum free fall, which I can show in a little bit on the turnaround. And in these, we're only varying the masses and the distance. So again, back to this equation, mass and distance. That's all we're varying. Everything else is held constant. I think this is my last slide. Yeah. So gravity is the word that we use to describe mass attracting mass, just like acceleration is the speeding up or slowing down of velocity. The force of gravity is dependent on the two sizes of masses and the distance in between. And then the last thing I want to say before I turn it over is other forces can be applied to masses to change the net force, right? We have the force of gravity, but we do agree that there's the force of buoyancy, which can cause humans in water or in the Earth's atmosphere to weigh less or to decrease that force. So we have multiple forces acting on an object. No other theory, my contention is no other theory such as RDD has been proven to show why things fall toward Earth. So with that, I'll turn it over to you, Roger.
Well, thanks, Wesley. I appreciate that.
Awesome. Thank you very much. I gave you a minute extra, so if you want extra minutes, Roger.
Well, thank you.
Okay.
Well, that's cute.
Thank you very much. It was quite good. We enjoyed it. Must I share your screen, Roger?
Oh, yes. It's in there. Hurry.
Okay.
I have a quick little video that demonstrates there's a potential weight, not gravity. I'm not going to use the word necessarily because that's what they replaced it with. It's actually weight causes the acceleration. But there's different biases, different buoyancies, weight, mass, or whatever you want to call it, is subject to its medium at all times, regardless. And that determines the rate it falls in. If you don't mind, I'll play this.
A few days back, I went swimming with my daughter. My daughter's 4 years old and she's learning to swim. So you can imagine how the swimming session went, right? Most of the time, I'm holding her up in the pool and she's enjoying herself. So while holding her in water, I realize that she feels much lighter in water than when I lift her up at home. So how can you explain that? That's right, it's Archimedes' principle. And this same principle explains why a small steel coin sinks in water, but a massive steel ship can float. But before we do Archimedes' principle, you need to understand Archimedes' volume discovery. I have a video on Archimedes' volume discovery, so if you've not watched that already, do check it out. I'll be putting a link in the description below. Now, if you look up Archimedes' principle in the textbooks, Archimedes said, when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. The first time you read this, it sounds like a cryptic message from Archimedes. But don't worry. In this video, I'm going to break it down and really simplify it for you. Also, towards the end of the video, I'll be sharing a great mnemonic to help remember this principle. So do stay tuned. And then we'll finish off with our top 3 questions on this topic. Let's start with Archimedes' principle. So here's the statement. Since the statement is pretty long, let's go ahead and cut it down. So I'm going to cut out the word partially, and we'll consider the body being completely immersed only. Now, what are fluids? As the name suggests, fluids are things that can flow. Liquids and gases are collectively known as fluids. So let's take the simple example of water. So I'm going to replace the word fluid with the word water in this statement. So now the statement becomes, when a body is immersed fully in water, it experiences an upward force that is equal to the weight of the water displaced by it. Now let's cut this statement into 2 parts. The first part is, when a body is immersed fully in water, it experiences an upward force. And the second part is, the upward force is equal to the weight of the water displaced by it. Let's understand the first part with a simple experiment. So when a body is immersed fully in water, it experiences an upward force. And that's very easy to see, because if I leave this ball, you can see it bobs up. Why? Because water is pushing it with an upward force. And this upward force is also known as upthrust or buoyant force. And you can try it out yourselves at home. All you need is a bucket of water and a plastic ball like this. So when you hold the ball down like this, you can actually feel the upward force on your fingers. So I'm feeling the force here. And again, when I leave the ball, the force brings the ball up. So how do we measure the amount of upward force? We know that an object feels lighter when it's held in water as compared to air. Now, why is that? That's right, it's because of the upward force of water. So the difference of the weight in air and the weight when held in water will give us the amount of upward force. Let's go ahead and try it out. For this experiment, I've taken this hollow ball and I've filled it with coins here to make it heavy. Let's measure the weight of this ball, which is filled with coins, with the help of this spring balance. So let's see what is the weight here. So as you can see here, the weight is 500 grams. Or to be more precise in physics, the weight is 500 gram force. But for this video, we'll just keep things simple and use gram as the unit of weight.
Okay, and I'll stop it there. You get the idea, right? Basically, the amount of weight is going to displace the same amount of water. and it does. That's just basically all I have to say about anything in any medium, including air, water, or let's say oil. It's going to displace that same amount. And the rate it falls at is due to the weight that's displaced. Sorry, excuse me. There was no gravity included in that equation at all. Just weight. Gravity, just a word you guys use. That's all I have to do to present what displacement is, disequilibrium.
Okay.
Then,
Can I go into
over to you.
can I go into my rebuttal then?
Yeah. Thanks, Roger. You go ahead for your 5-minute rebuttal, Wesley. Sure.
Yeah. Thanks for that, Roger. I'm going to share my rebuttal before we get to discussing what you talked about there. So, let's compare RDD to gravity. A couple things that I'd ask you to think about. Which theory has clear definitions? Which theory has quantitative relationships? So proportional, you saw the equation before. We can pull up an equation for Archimedes' principle and be happy to do that in the back and forth. And then in gravity, it has an inverse square with the distance between the center of the masses. So which theory has predictive equations? What I mean by that, can we use Archimedes' principle to determine how fast something will fall, or what kind of weight that it will actually have? Or can we use gravity to do that? Which theory has the backing of independent tests? And if gravity or RDD fails to do any of these, the theory is incomplete or invalid. So I'm going to go, let me do present from slide. Okay. So RDD claims that motion is caused by relative density differences alone, not gravity. I think you said weight, but we'll get to that in a minute. And objects seek equilibrium. Gravity is unnecessary, as Roger explained very well. And then how buoyancy explains falling. So what is RDD missing? It has no force definition. What's causing this? What causes the acceleration through a medium? Why are denser mediums lower? What is the reason that things fall down? There's no acceleration equation, at least that I've seen presented yet. There's no predictive math, so we can't form a hypothesis, a quantitative one, and then test it. If we can, then great. But we do have predictive math for both gravity and buoyancy. And Archimedes, in my mind, is buoyancy. There may be some technical differences there, but we can go over that. There are no experiments proving acceleration is solely due to density. These are the equations just the high-level equations for gravity and how it's measured. And I have yet to see one how RDD is measured. There are ones for buoyancy, so I want to be fair on that point in Archimedes' principle, but none for RDD by itself. These are the control experiments for gravity that RDD cannot explain. So again, remember, we are varying the variables, and in any of these, you will see that density is not changed in these variables. So Cavendish torsion balance, you change the mass. Remember, it's N1 times M2 over R squared. So we change the masses, the force changes. In vacuum free fall, we remove the medium, yet masses still accelerate downward. I have a site, we can go here later if it comes up in the discussion back and forth. Altitude dependence of G. If we do this vacuum test at a higher elevation, the acceleration becomes less because it's further away with the inverse square law of the distance from the Earth. Two masses of equal density with different force, we change the masses and then the acceleration changes. And none of these are we changing the density of the masses. So my final closing on this before we get into open discussion, gravity is quantified. RDD is simply descriptive. Gravity we can predict and measure and test against those predictions. RDD is more descriptive and doesn't really have a quantitative measurement. It's not predictive. Engineers and scientists use gravity every day, calculations of gravity and the forces needed to get away from gravity or to get out of the field of gravity here on Earth. RDD, it's not used. And so I would just end on this. If it can't calculate nor predict, it can't replace gravity. So that's, I'll cede the rest of my time. Thank you.
Thank you very much, Wesley. Really good. Yeah, it's up to you, Roger. You have something to share again, or?
Well, I did have a little clip from the same guy, but if you don't mind, give me a second. I'll go grab it.
Okay. Because this is the rebuttal 5 minutes.
Yes.
Okay.
Let me know when my time starts, when I get it. So.
Yeah, when you're ready, we'll start the time. Just want to say hi to everybody in the YouTube land. Hit the likes, share the show. Thank you for coming. You guys rock.
Flatzoid, when are you coming home?
As soon as I can. Hopefully Monday or Tuesday, I hope. I mean, I have to start work in a week, so.
Is your car up and running yet?
No, it's going to stay here.
Okay.
No, it's going to stay here. They have to take the engine out and everything, so it's going to be out for a while.
I was going to give you how we measure displacement. So
great.
It's the Eureka moment by Archimedes.
Okay, let's see. There we go. Okay, I'll start your timer now.
Okay.
Okay. Done.
Play thing. I'm having problems with my mouse today. I had to replace the battery.
I'm sure you must have heard of the famous crow and jug story. It goes something like this. Once there was a thirsty crow, but the water in the jug was low. Pebbles in the jug he did drop. And the water rose up to the top. The crow drank water and was no more thirsty. This is an example of Archimedes' discovery. And this discovery of Archimedes regarding water displacement is going to be the topic of this video. In this video, we'll be talking about Archimedes' volume discovery, and then we'll do our top 3 questions on this topic. In the next video, our focus is going to be on Archimedes' principle. So you can watch that video after this one. I'll be putting a link in the description below. And once you watch the 2 videos, I'm sure the concept is going to be crystal clear to you. Let's start with what I like to call as Archimedes' volume discovery. Now, as the legend goes, Archimedes discovered this while he was taking bath. So as he was entering his bathtub, he saw the water overflowing. And then he had this eureka moment. He discovered that the volume of the liquid displaced by a body is equal to the volume of the submerged part of the body. So if the entire body is underwater, then the volume of the liquid displaced will be the volume of the body. And the crow used this concept in the crow and jug story to push or displace the water up. So then the volume of the water displaced was equal to the volume of the pebbles. Let's understand this concept with the help of some experiments. I'm going to lower this ball into this beaker full of water like this. And as expected, you saw that the water overflows into the bowl here. Now, why is that? Why is the water overflowing? It's because the ball is squeezing the water out. There's no more space, right? But it's hard to measure the volume of the water displaced accurately because, as you can see, all the water has not gone into the bowl here. Some of it is still sticking to the beaker. So some water is wasted here. So let's try this experiment differently. So now I'm going to tilt this beaker so that the water overflows into the smaller beaker here. So let's go ahead and do it one more time. So I'm going to lower the ball again. So as you can see, this ball has displaced water into the smaller beaker. Now, what is the volume of the water displaced? It's 200 ml or 200 centimeter cube of water. So by Archimedes' first discovery, the volume of this ball is the volume of the water displaced, which is 200 centimeter cube. Now, how can we verify that? So we know that this ball is a sphere. Now, what is the formula for volume of a sphere? It's 4 by 3 pi r cube, where r is the radius of this sphere. So I've actually gone ahead and checked that with the help of a vernier calipers. So I went ahead and measured the diameter of this ball here, like this. And the diameter of the ball is 7.2 centimeter.
56.
So the radius is 3.6 centimeter.
I'm going to
And
stop
now
here.
if I use the formula 4 by 3 pi r cube, I'm getting the exact same volume.
Good God, it won't stop. Thank you. Yeah. So basically, this works in all mediums and pressures. The volume of your object, like in a cylinder, for instance. So that's the size of the cylinder is going to replace even the pressure in air and gas in all mediums. So you can use this equation to calculate anything. You can build any kind of engine. All mechanics revolve around this principle. So I don't understand when you say how you can't use this in engineering. That's the only thing I can rebut. Yes.
Okay, so yeah, that's it for the rebuttal.
Yeah.
We're going now into 15 minutes open discussion. If you guys want to go on for another 15 minutes, we'll decide then. But yeah, I think Wesley, you go on because Roger just spoke, so you can start.
Sure. I've got a couple questions for you based on that. So he said a couple things in there that I was curious if you believe what he was saying. He said that the force was offsetting the weight of the object. So do you think the weight is a different force, or what are you thinking that the weight of that's being offset in those experiments that he showed?
Well, it's the volume of the mass that's causing the force within the medium.
So what he said that the buoyancy counteracts the weight of the object. So the buoyancy is the force, or I don't know if you're calling that RDD, but what is the weight of the object? How is that different than Archimedes' principle?
Well, it's the amount placed in the volume.
The amount of what?
Mass. Weight.
Okay. Do you know that mass and weight are different?
Yeah. But I don't think anybody has a true definition of what mass is.
No, yeah. We don't need to fight over the definition of mass. I'm just asking, do you know how you get force from a mass or weight? Weight is a force. So do you know how to get weight or force from a mass, how to calculate that?
How to calculate it?
Yeah. I showed it in one of my descriptions. This isn't a gotcha or anything like that, but
no, I didn't think it was.
Okay. Do you know? I can tell you, but I just don't want to.
Well, you can give me your description of it.
Yeah. So force is equal to mass times the acceleration, and when we're talking about the downward force, your weight, it's mass times g, the gravitational acceleration due to gravity. Sorry.
Okay. Yeah, but are all masses subject to this?
Yep.
Are they at equilibrium until the force is acted on?
Nope.
So, like if I set something down on a table or in any at rest, they're subject to this so-called gravitation at all times.
Oh yeah. Yep. That's why we have weight. Yeah. When you step on a scale, that your weight is causing the scale to move. Some people would say the mass, but it's using the acceleration to cause the weight to move.
So when I step
To
on a
measure your weight.
scale, I am literally accelerating.
Yeah, that's Newton's perspective, but Einstein would have it different. But the point is, you weigh something, so there's a downward force on you in Newton's paradigm.
In Einstein's paradigm, which is actually the one that consensus goes with now. So could you?
Yeah, like
elaborate
I said, Einstein boils down to Newton. He said that many times. And that was one of the points of his experiments. It had to boil down to Newton because Newton's law of gravitation is a law and it's observable all over the earth. So my question again is what is causing weight? The mass and what else? Because mass is not weight. The mass and what else is causing weight here on Earth?
The mass is causing weight?
No, I'm asking you.
Your mass is actually a measurement of your weight.
No.
Yeah, it is. Can you show otherwise?
Mass is the
amount.
amount.
How else would you just demonstrate it?
Mass is the amount of material. Weight is the force that mass has.
Weight is a force?
Yep.
Do you have a definition?
Of what?
That describes this. Your weight being a force.
Yeah, weight is measured in newtons, whereas mass is weight or force is measured in newtons, and mass is measured in kilograms.
What's the difference between the two?
Kilogram is a unit of mass. You would need to multiply that by the acceleration, which is the acceleration due to gravity, which is small g, and then meters per second squared is acceleration. So kilograms times meters per second squared equals newtons. That's force.
Okay. So can you demonstrate this right now?
Yeah. If you drop two things, they fall at the same rate, and then you can weigh both masses, and you get the force of gravity for each mass.
So when they reach their full velocity,
that's the acceleration due to gravity, right? What do you mean full velocity?
When they get the terminal velocity is a better yet. Do they actually weigh anything? Can you weigh them at that point?
Well, if they're falling, you could have a scale and free fall with it. It wouldn't weigh anything. But why does it stop accelerating downward? It would be the question I would ask.
Well, it reaches terminal velocity, but it's due to the medium. It slows down.
The medium causes it to slow down?
Yes.
Would you call that friction? Would you call that friction, or would you call that relative density disequilibrium?
I would say it's a disequilibrium. Yeah, it's a relative density to the medium that it's in.
Is
the
that
medium
also,
changes?
Would you also call that friction?
The closer you get to Earth, the medium gets thicker, you might say.
Yeah, why is it thicker closer to Earth?
Because that's where it's produced.
What produces it?
The gas changes the phases of liquids and fluids in the medium.
So gases produce more gases?
No, they're produced here on the Earth. All gases are.
By what?
Yeah. By what? Heat, temperature, phase change between liquids.
That produces gases here on Earth?
Yes.
Okay.
They do.
And if you think that, then why don't they?
I don't think that. I can. That's been demonstrated.
Okay.
Like water does change.
Okay. Fair enough. Then why doesn't it accelerate upward? Why don't we have huge rushing winds upward?
Winds?
Yeah.
Winds go up?
I'm asking you, if the gas is produced down low and it's much denser down low, the winds are always constant, and that has nothing to do with which direction they're going in. They run into thicker gases down here, and the winds slow down in that process. It doesn't have a direction to it at all. Okay, so winds are always constant?
Yes, they are, dude. You can pull up any weather map. You can see this. Okay.
And so since it's denser here at the surface of the Earth where gas is produced, then it's less dense higher up. So if gas pressure tries to equalize, the winds would always be moving upwards in our atmosphere. Is that what you believe is happening?
No, gases are not subject to gravity, dude. Like
I'm not.
they're,
I never mentioned the word gravity. You said I'm using your model. You said that gases are denser here on the surface of the Earth. They're lighter up top, higher up.
they're dissipating. That's what happens when the winds have effect on gas. They get pushed around. They get moved. They're free flowing. They're not bonded.
Okay, so why don't they equalize upward so that it's equal density, right? You say it searches for equilibrium. Why doesn't it rush upward like a can of soda when you open it?
They do, but they dissipate as they go upwards too. They don't go in any. They go in all directions.
Okay. The other question I have is, do you have a formula for RDD?
No, I don't have a formula for it. It's due to each medium is different. So you would have to figure each one out. That's why you have this thing called specific gravity. You actually do equations with, which is basically RDD with a gravity dressed up on it. That's really
okay. What are those equations? What are those equations?
I haven't studied them all. I don't know, but they are different. They do differ.
What differs?
The amount of force you have to apply to something in each medium to get them to go into motion.
And what are with
any system like that? There is no independent force. They're just a different bias due to its weight. And there are lighter gases that actually do go up. They're not a big rushing force because they don't have a large amount of mass.
Okay. So what would be the variables? What are the variables in your experiment for RDD, or in any experiment for RDD? What are the variables?
Well, in natural sciences, there's only a few variables because I like to stick to the nature of things.
Yep.
The transfer of energy, hot and cold, is usually the variables that are applied in this situation.
Okay.
The higher you get up, the colder it is, the slower the gases move.
Well, because
the lower you get, the hotter it gets, the faster the gases move. That's how you get weather, dude. If we didn't have containment, we wouldn't have weather to begin with.
Okay.
We didn't have a pressurized system to begin with.
So it seemed in his experiments, and correct me if I'm wrong, he mentioned the density of the fluid and the volume of the fluid that was displaced and the weight of the object. Would those be also variables in your system or no?
Absolutely. But if you can place the same amount of weight over a greater distance, and you will find equilibrium a lot faster. Yes.
Okay. I just have two more questions, and then you can ask me about gravity. I'm just going to present my screen one more time. Where do I go? Here we go. Present. So he was showing a good experiment for Archimedes principle, which again, I agree with wholly. We call that buoyancy, and that's another force other than gravity. So here, let me share my screen real quick. I'm going to do this one first. Okay. Let's go to this. So he was using Archimedes principle, which I, again, wholly agree with. His principle states that any body completely or partially submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid. And he said that displaced by the body. Is that kind of what you're going with, or is it different than that?
No, that's what Archimedes went with. That was his principle.
Okay. I mean, that's the experiment you put forward when you were discussing RDD. Okay. All right. That's what, and it deals with buoyancy, which I agree with. So they're saying that it can be quantified with different variables. And so this is the mathematical formula for that. So the force, we call that the buoyant force, is equal to, I think this is rho. I might be wrong on that, but rho is the density of the fluid. So we talked about that. So I agree with that. The volume of the fluid. And then do you see the G down here?
What about it?
Do you see what it says? I don't, can you see my screen? Sorry. Do you see my screen?
Yeah, but that's not part of Archimedes' original principle at all. There was no G in it.
Oh, what was it before G?
It was weight.
So it was an actual force and not a acceleration.
Yeah, there's not an acceleration if you're actually building something or anything. There's not an acceleration required in engineering.
Okay. Well, so I agree with this one, but it depends on gravity. Without gravity, you don't have Archimedes' principle. It's core to the foundations of Archimedes' principle. So I'll just state that. If you want to respond to that, that's fine.
It wasn't involved in any of his equations when he first came up with the principle.
Okay. If you could wait.
It wasn't even in thought of at the time, and you know that already.
Okay. If you could provide what his citation for that when I hand it back over to you. I just have one other question for you, and I have to share a different slide, so forgive me. Stop screen, present a new screen.
I'm just going to state it. It was just the volume that's displaced by the volume that was applied. It's pretty simple.
That's fair. Okay. I'm going to share this because I think this was the guy that did your, wait, it's not working. Let me try one more time. So the person, here, shoot, I can't tech as usual. Share screen. This is my last question, and then I'll leave it up to you, or we can go back and forth more. So this is the guy that you used, which I've watched his stuff. He's a pretty good dude. And so this was the thing that you showed. I'm just curious, have you watched or listened to any of these?
I have watched the ones where he actually goes into gravity. So I do know he glints to consensus. The fact of the matter is that I don't even think Newton proved his own theory about the mass of the Earth. And the janky experiments that you guys have shown, like the mountaintops that they calculated the density of the Earth, were not really validated either. They were done with extreme prejudice, with a pre-assumption of a sphere Earth floating in a vacuum to begin with.
Okay, so it has been 15 minutes. I don't know. You guys want to do another 15 minutes?
Yeah, let me just finish up on mine, and then if Roger wants to ask any questions, then he can go for as long as he wants, because I kind of monopolize the time, so I want to give him fair time back. But so you agree with him on Archimedes, you just don't agree with his thoughts on gravity?
Yeah, I mean, I don't agree with gravity at all. That's my point. I don't think it's ever been proven. But
he would say that he used weight in all of the. Hold on a second. In all of the videos that you showed, he kept mentioning the displacement of the weight or the medium caused by the weight. And so he would say, and as most scientists would say, that the weight is caused by gravity. But you disagree with the gravity portion, but you accept him as a good source on Archimedes' principle, right?
Well, he just demonstrated it. That's all.
Okay. But the demonstration of gravity are not true or fake.
No, we're not saying they're fake. They're biased.
What do you mean by that?
Fake. Did I say it? Well, for instance, like dropping the objects to a lighter object and a denser object, they did not get full time to reach their full speed they would actually have due to the medium they're in. Okay, let's say I'll give you the example. I'll rephrase it. Actually, better way, like the ping pong ball and the solid ball he dropped. They did not reach their full potential in the medium. You have to give them more time to get there. You're in a thin medium, and there's resistance against the lighter object, but they didn't get full time to get to that point.
Okay, what about in a vacuum when you remove the medium?
It's removing the medium. There's no point in nature where there's no medium, dude.
Oh, I know, but what in a
natural experiments, naturally science, that vacuum chambers are not a natural occurrence.
Okay, anyway. So in a vacuum chamber, why do things fall down if there's no medium?
Because there's no medium.
So there's no density.
There's no density, no disequilibrium at all in a vacuum chamber. No.
Okay, so why do they fall down at 9.8 meters per second squared?
Why do they fall down at that rate?
Yep.
I'm not sure.
Okay, that's all I had. So you can ask questions.
Yeah. Well, how do you determine that it's the gravitational pull of the Earth that they fall?
Yeah, so we can isolate all the other variables. So again, gravity is the formula for gravity includes the two masses.
Well, I'm not looking for a formula for gravity. I'm looking for gravity.
Okay. So the variables are mass, the two masses, and the distance between the two masses. So you can vary any one of those, and every time you vary one of those, you change the force, or you change the acceleration.
What are the variables you change?
I just told you the two masses and the distance. Okay. Those are the variables that you change.
Distance equals gravity, is what you're saying. The gravitational pull is due to distance. So let's say you had an infinite vacuum chamber. Would it increase the rate that those things fall at?
So again, real quick.
Further away, let's say we built a vacuum chamber that's actually, I say, 70 feet high. Would you drop those? Would the rate of that speed actually increase as it got closer to mass?
Yes,
it would. Have you?
Sorry, the acceleration would change. The lower you are to the Earth.
No, I'm talking about it in a vacuum chamber. Just dropping it in a vacuum chamber. Would the speed of that object get faster as it got closer to the Earth?
Is the vacuum chamber on Earth, or where is the vacuum chamber?
You can put it anywhere you want. Is it going to change the speed?
So you have to have what mass you're comparing it to. So if you're saying the Earth, then yes, the closer you are to Earth, the faster, or the
okay.
So hold on a second. Let me finish. The greater the acceleration would be. So higher up, like on Mount Everest, this is what critical think did. He measured the gravitational force at different heights, and he got the predicted outcomes. There were some other variables in there, but yes, you weigh less higher up.
That's due to what?
The gravitational field.
Well, what are the other variables?
I just told you the two masses and the distance.
No.
Okay, wait, you asked me for the variables. Those are the two variables that are used to calculate the force.
There's the only two variables that would have any bearing on that, right?
On the force of gravity, yes, but there are other forces like buoyancy and friction.
See, you're making the assumption that there's a force of gravity instead of actually proving it.
Nope, we proved it.
How?
I proved it.
Give me the experiment that proves gravity.
Okay, many. Cavendish. You changed the masses.
No, Cavendish was not necessarily gravitation. It was density of the Earth, the mean density of the Earth. That's what Cavendish was trying to prove.
That may be one thing that he did, but he proved the big G, the gravitational constant G, big G.
He did?
Yep.
Cavendish did.
Yep.
That's good. All right. Show us how he did this.
His experiment.
I like demonstrations, Steve.
Yeah, Cavendish. I have have you not seen a Cavendish experiment? It's basically
I've seen a lot of them. Yeah.
Oh, okay. Well, then you understand how it works. So, what?
I've seen many different ones. Yes. Okay. There's so many, but I've never seen one actually practically demonstrated. And I keep hearing it all the time, but I've never seen it practically demonstrated.
Oh, multiple universities do this. So I could recommend a local university to you if you want to go actually see it.
Yeah, like Harvard would be a good one, but I know what they do at Harvard with their demonstrations. So.
How do you know that?
Oh, I checked into it.
Oh, you've been there?
No, I've checked into their experiments. I've looked at it online mostly. But
okay, cool. Do you have any questions?
I think that they're making an assumption that there actually is an attractive force between masses.
No, that's what they tested. That's the cool part about it, right? That's what they tested. Okay. Yeah.
And how do they isolate the gravitational force between two lead balls?
By controlling for all other variables, and then
what will be the other variables?
Performing it. Density, airflow, electric charge, buoyancy, all those things. You can hold them constant, or you can change them. That's why like the vacuum chambers are a really cool test, because there is no medium there, but yet the masses still fall down, and it doesn't matter the size of the mass; they still fall down.
Well, I never seen a Cavendish experiment going to the downward vector. So.
Yeah, the Cavendish isn't the downward vector. That's calculating big G. That's the coefficient, and that also shows that the masses get closer together. There's a force there. That
I saw a really cool demonstration with the Cavendish one time, and they actually took a lead weight and they put it below the actual lead balls, and it actually pulled down to the lead ball.
Yeah,
automatically. But any other object they put below it, it didn't pull toward that at all. It's like there's some kind of flow between the two.
That would have been a great experiment to show on this to debunk.
I've done it on my channel, actually. If you want to go watch it, I have a couple of demonstrations.
No,
that show
this is why we're here. So if you want to show that, that'd be fine.
It's going to take me probably an hour or two to dig that up. But I mean, I deal with this stuff constantly. I go through the experiments, and there are other different variables that they didn't really take account for in the process. I don't think they took any kind of electromagnetic bias between leads, and matter of fact, it seems like they use that as their go-to. It's like it does pull toward each other. Yeah.
No, they ground it so they're at the same potential, so you don't have to worry about that.
He didn't. The one that I had, the ones that I've seen were never grounded necessarily.
Oh. Can you put the citation?
But, I mean, I have a citation. I've looked at the experiments, and my conclusion was that it seems to be a connection between the two. And the small variable that you get out of it is the weak force that you call it is not a constant. It doesn't seem like it's a constant in any of the Cavendishes necessarily.
What do you call the weak force?
Well, your gravity.
You think gravity is the weak force?
Yeah, gravity is a weak force, and even your physicist actually stated as a weak force. So it's known as the weak force.
So you didn't bring the other couple examples that you think disprove or debunk gravity, but so in that case, would you say that you are the citation?
I am the citation. Well,
no,
I guess. I mean, if you want to go watch my channel and watch my demonstrations with or the experiments that I've reviewed, you can go there.
Yeah. Okay. Yeah. Cool. Do you have any other questions before they open it up to chat, Roger?
That's fine with me. No, I don't have any more questions. I just don't. The constant rate of fall of objects are due to their density, right?
No,
they're not at all. That's the contention. So let's say a ping pong ball is just as dense as a lead ball.
Okay, let's just say that.
Okay, so you drop them at over distance, and that would be your variable, right? Would they not change over?
What's the variable?
Their densities. There's two different densities between let's say a ping pong ball and a solid lead ball. Correct?
Did you not just say that you would have a ping pong ball with the same density as a lead ball? That's what you just asked.
No, I didn't. I did not say that. No, I said they're not the same density.
Oh,
the density is variable.
Yep. Yeah. And they fall at the same rate in a vacuum. They
over distance. Yep. They'll be no matter how far the distance. They'll be falling at the same rate.
Mm-hmm.
You have a demonstration?
Yeah, that the brick and the feather. It's not a ping pong ball, but we could do that too.
The brick and the feather fall at the same rate.
Yep.
In a vacuum.
Acceleration. Yep.
So the only thing you vary there is nothing to do with gravity at all. It has everything to do with the medium. That's the variable. You remove the medium out of it. That's what a vacuum is, correct?
Right. Why does it fall down though in the vacuum then?
Why? That's the bias it's at.
Yeah, gravity.
Gravity is a downward bias. So what is the cause of the downward bias?
The mass of Earth.
Is it? So how do they calculate the mass of Earth? Can you show this calculation?
Yeah, they did it with Cavendish.
They did?
Yep.
No, I don't know. He wasn't conclusive on it. As a matter of fact, he said to himself, that's why they did all those other experiments with the mountaintops.
Yeah, one experiment isn't conclusive. You got to really.
Yeah.
So let me just respond to that. One experiment is not conclusive. I agree 100%.
That's why they did several of them.
Hold on, let me finish. That's why they do it. Yeah, hundreds and hundreds of times. Right. Yeah. I would agree with you. It's not conclusive when you do it once. You have to do it repeatedly. That's the position of science. So. I don't have any more questions, Flatzoid. So thanks for hosting again. And thanks for a polite conversation, Roger. It was really good.
Oh, no problem. I don't mind the argument at all.
Yeah, I think it's really good. You could still go on for another 5 minutes, or 6 minutes until 10 o'clock if you want to give people the time to get the questions in. Yeah. We do have a few questions at least. Just to let everybody know, this is your time to get it. 6 more minutes, and then we'll go on to Q&A. And super chats will be read first. So thank you very much for your guys' support.
I can bring up a couple cool experiments real quick because I didn't get to them. Hold on one second. I will pull it up because I have a link. Okay. Let's see if I can go to it. They have a cool, yeah. Oh wait, this isn't the right one. Give me a second here. I think this is it. That's not it. Let's try this one. Yeah, this one. Okay. Yeah, okay. I'm going to share my screen. Share screen. Share screen. And I'm just going to do share window. I think this is it. Share. Okay, so this is the ball and foil. So they have a vacuum chamber and they're going to do a ball and foil in here. And this is where they calculate the acceleration. Both of them are at 9.8 meters per second squared. So no vacuum and within a vacuum. You see the tin foils going down slower. I'll play that one more time. So again, on the left, there's, oh, can I go back? Let me pause it before. Okay. So on the left here is going to be the no vacuum. And in both, there is a tin foil and a lead ball. And they both, and you'll notice on the right, there is a vacuum and they fall at the same rate. So let's go with that. You see that on the right, they came at the same time, and with normal air pressure, that's what we would call buoyancy. So the force of buoyancy is causing it to fall down slower, or in that case, actually, I think it's more about air friction. It could be a combination of the both, but yeah. So just want to share that. So I guess the only other thing I would ask, I want to go back on it, is you said that, how do I cancel this? Stop presentation. Stop sharing. There it is. You said that you don't exactly know what causes weight. I think you said mass or things just have weight. Is that accurate?
Yeah, everything has a weight to it.
Okay. But what causes weight? You don't know right now.
There's no cause for weight. Everything has a mass to it, therefore it has a weight.
Okay. Okay. So, do you know why the weight is, well, okay. So you have no cause for weight. My cause for weight is gravity. Force equals M times A. In this case, for gravity, M times G. So that's what my contention is. If you don't, that's fine. But density doesn't explain that, or RDD doesn't. So that's my final closing. So I appreciate the good moderation, Flats. Thanks, and thanks for talking with me, Roger. I'm ready for questions.
Okay. I don't have really a rebuttal for that. I can just guarantee you that everything has a certain weight due to its density.
Yep.
That's a fact.
Okay.
It has nothing to do with any force.
Okay.
Well, that was a good
Yeah.
debate. Thank you, guys. I appreciate it from both of you guys. Thank you for keeping it clean and cordial, like I knew you guys would anyway. Made it very easy. Thank you very much. Guys, let's send some through questions. I think we'll go through some of them. If you have any more questions, guys, you can send through. We'll start with the super chats. Thank you, Jake Fetter. He was more of a statement rather than a question, but because he did send a super chat, I'll read it out. He says, so Roger is just phoning it with someone else's video presentation. Why even show up? Just send the videos, bro. So that's for you, Roger.
Thanks. I appreciate that. But I mean, he did exactly the same thing just now himself. So yeah. Why even show up, Wes? Why'd you show up? But come on.
Well, to be fair, I did have a presentation and used my own.
Well, you had a PowerPoint, but you didn't show a physical demonstration.
Yeah. Okay. Cool.
That's basically what he's naming it. I mean, you didn't have your own demonstration, neither did I. I don't have a lab like handy. It would be really cool if I did. The only thing I've gotten close to a lab is a bench, and that's about it.
Yeah, no, it's really nice that we can rely on other scientists who do have that and use what they've found and use their descriptions and experiments.
Thank God for the internet, right? It's made life so much easier over the past 20 years, hasn't it?
Okay, and then we got LJ for another super chat. Thank you very much. He says, at what size does ocean and seawater start to curve? I think that's for, obviously for Wesley.
Yeah, so on sea level, the ocean curves at 1 degree per every 69 miles.
I love a demonstration of this.
Yeah, I mean, if this was a debate on the shape of the Earth, I would prepare for that, but it's not.
Me too. I have plenty of demonstrations of that.
We could do another one sometime if you're agreeable to it, but that's not this debate. But thanks for the question.
Then it's going to go into like a refraction index, which is going to get really weird because that's not really physicality necessarily.
Yeah. Unfortunately, that's not the debate topic for tonight. So thank you for the super chat. Okay, and Dick Wayne says, only one question: how can adults still believe in space-time filled with gas balls?
Did you say Adam? What did you say? What was it again?
Folded.
How can adults?
Adults. Read it one more time for me.
How can adults still believe in space-time filled with gas balls?
So the reason that I believe that, or I guess I would say believe that, is because I believe there's a lot more evidence to show that to be the case. We can argue about that later. Again, that has nothing to do with gravity, but thanks, Dick Wayne. It's always a pleasure talking with you.
And then we just got a
sarcastic.
What's that?
That almost seems sarcastic there.
No, I love talking with Dick Wayne. Some of my friends don't even like that I talk to him that much, but he's always fun to chat with.
Yeah. It's good to have people with different points of view. Yes.
Oh, I love it.
We've got another super chat. This is for you, Roger. Okay. Thank you, Buckstard Buster. Thank you for the super chat. He says, can you ask Roger to play his video at 10:50 in? I don't know if it's the first or second video.
Yeah, good question. I have no idea.
Yeah, 10 minutes and 50 seconds. That's the question asked for you, Roger.
What do you think I should do? Play the video? Because I'm pretty sure he's going to have a bias to gravity, so I'm not going to.
I might have it while we get through these questions. So if I find what he's talking about, I'll pull it up. But
which video was it? I did.
I got it. So just give me a second. I'll put it right up. I'll put it right up now. Because it's a good video. I like this guy. I haven't seen him very much, but I'm gonna definitely tune in now that Roger brought him up. Okay, so let me present. I will share screen. Archimedes principle. Share screen. Archimedes principle. So share. I don't know if I can share. Also share tab audio. So hopefully you can hear this. If you can't, you'll get the gist. Okay.
There we go. Yeah.
Displaced. And we know that weight is mass of the liquid into g, where g is the acceleration due to gravity. Now, what is the formula of mass?
20 more seconds.
It's volume into density. So we get that the upward force is v into d into g. But I like to write it as VL dlg, because it helps me remember that it's the volume and density of the liquid displaced and not the volume and density of the body. So let's go ahead and add this formula and then.
All right.
I see an upward force, not a downward force.
Sorry, did you miss the part about G?
Yeah, I got the G part, but he's calculating for an upward force.
Yeah, to counteract the downward force, the weight that he was talking about earlier.
So you're saying there's a constant pull and a push at the same time.
Yeah, with it's two forces. That's what
gravity does both.
Yeah. That's what the two forces are, right? Gravity is the downward force, buoyancy is the upward force, the Archimedes principle. So, yeah.
I just think it's displacement. That's all it is. But that's my opinion.
Yeah, we know that. That's fine. You presented your argument.
Yeah. So, I mean, whether he said that or not has no bearing on anything whatsoever.
Yep. Thanks for citing him.
That's not a problem, man. There's not a whole lot of
Okay.
citations on our side if you know. There's an extreme bias towards the heliocentric model.
Yep.
Thank you. Santero also sent in super chat now. Thank you very much. He says, can you ask Wesley, how does he measure the convexity of water? Can he show a demonstration?
Yeah, sure. So I can't show a demonstration right now. Again, this is off topic, but I would be happy to come back and do that for anybody else. If Santero, I'd love to debate you on it. But basically what you do is you look at the North Star and you're on a ship and you travel northward toward the North Star. The North Star increases in elevation 1 degree every 69 miles. So that's a good proof of that if you believe light travels in mostly straight lines. So that's the answer for that.
So all light's parallel now, is it?
Well, that's not on topic, but yeah, I said if you assume that. So
It's an assumption, yeah.
Yep.
Cool. Thank you very much. And then we have Bendy Horizon. Thank you. He says, what about curvy spacetime? Can you demonstrate that?
Yeah. So curved spacetime, there were a couple of them. I'm going to forget his name, but after Einstein came up with his theory of relativity, what they did to show that spacetime curves is they measured the apparent location of stars around the eclipse of the sun, and they were off by a few degrees from where they should have been. And that's because, and they predicted this, Einstein predicted this. Before this, he wasn't in very good standing with the community, but after, he predicted that they would show up at this other apparent location, and they proved it. I can't remember the name of it. It might be Ettinger or something like that. Another one is satellites. They can't use normal clocks. They have to, I can't remember if it's speed up or slow down their clocks in order to keep time with those of us on Earth, because space-time is curving where they're at. So yeah, those are two good examples. Thanks for the question.
Roger, you have anything?
Oh, with the satellites and the bending of space-time? That's a good question, man. I can't demonstrate any of those. So until I actually see these actually in reality, actually working, yeah, I assume they're not existent.
I apologize. The name of that experiment, look it up. It's really good. Is Eddington. Before Einstein didn't have much pull, and once he made that prediction, the solar eclipse came and they measured it. That was the Eddington observation.
I do have a little video on Does the Earth Move? It was put out by Eric Dubay today. It actually explains Airy's failure if you want to look at that.
Yeah, we can do that next time, but we're just answering these questions right now.
Yeah, it just shows their predictions are off too. So, namely, a lot of you guys' predictions are apparent predictions. They're not geographic locations of these said objects.
Okay, the next one we got from Sam. Thank you, Sam. He says, what is gravity? You assume a cause of an observed effect.
That's really cool. We can actually prove it's the cause. Again, I know Sam doesn't like the word gravity, so we could use a word. Let's just use giggity. We could use that because that's the description of mass attracting mass. And so that's been proven multiple times over. Look up Cavendish and look at all the thousands of times it's been performed. And I'm just curious, Sam, why you think Einstein was a PDF. That's kind of weird. But other than that, yeah, there's multiple proofs of that. And yeah, and also perpendicular lines require 90-degree angles. So that's another proof of like tangent horizontals. Go ahead, Roger. I don't know if you have anything to add to that.
To tangent horizontals?
No. To the question that he asked. Sam had some other questions that I was helping him with in chat. So
I think he was directed that question at you.
I know. Oh, yeah. I didn't know if you want to respond to my response. That's fine.
No, I don't have a response for it. I'd like to see it demonstrated.
Yeah.
Okay. Then we got Soggs. Thank you very much. He says it's for Wesley. My question is, why, Wesley, are you going against what the Bible says?
Who said that?
Soggs.
Okay. I don't think I am. We can have another debate on this. Flatsoid event, and I have talked about it numerous times. It's my well, not mine interpretation. I rely on biblical scholars. I know there's a heated debate over that. And so I know that it's not 100% positive, but I'm fine with that. There's a lot of interpretation no matter what you read in scripture. And so that's my answer to that. But I'm not really going to debate religion today.
Awesome. Thank you very much. Roger, you have nothing to say? Okay.
About what Sog said, it was directed at Wesley again.
Okay. Yeah, I just want to give both of you opportunities on all the questions.
Absolutely.
Unfortunately, most of the questions seem to be for Wesley. So if you guys have any questions for Roger, please give us questions. Some again says, where did you get the R value?
I don't know what he's talking about. In the formula, that's just the distance between the masses. So it's not the radius value of Earth. You can use that for things on Earth because we know that radius, but we didn't discuss that in this presentation, but there's multiple ways that you can get that.
You know where he's going with it anyways.
Yeah. I mean, if we were going to debate on the radius of the Earth, I'd be happy to debate that, but that's not what we're debating, because that R value, it works for the orbit of the moon. It works for the orbits of all the planets. And so, so that's one confirmation that the R value is correct. There were other ways that the R value was measured, not just through gravity measurements.
Awesome. And then again from Solve, he says, where does mass get the perpetual energy to create a force, and why does it never run out?
Yeah, so it's not a battery. Mass was put together and has inherent energy in it. And so it's not going to run out. It's like, I'll liken it to a permanent magnet. I know what people are going to say, but it never runs out of energy unless you heat it up or do other things with it. So it doesn't require, the energy was already put into the mass, and force doesn't always require energy. They're just fields.
I've never heard energy described as a field. But...
Nope, the force is.
Cool.
Okay, and then Bendy Horizon says, Wesley, why globers never measure the curve of the alleged spin of Earth? Why do they always have to take it unprovable theories or maths?
Wait, repeat the first part of that. Why do the curve of the spin of the Earth?
Yeah, why globers never measure the curve of alleged spin of Earth?
Center or spin?
It should be curve and spin. I wouldn't say curve or spin of the Earth.
I don't think we say the center or the spin of the Earth curves. That's a weird question. So if you want to restate it, I'll answer it.
Yeah. And then Glenn. Oh, sorry, Roger. You want to say something on that?
Oh, yeah. Well, I was just going to say that Einstein actually said there was no optical experiment that could prove the rotation of the Earth. The quote here. Yeah.
Yep. In our reference frame, I think that's mostly true. I would defer to anybody smarter in the chat about that in particular, but in your particular reference frame, without outside observations, you wouldn't know.
Yeah, including all these like jinky experiments like Michelson-Morley and all the rest. Yeah.
Maybe I think pendulums, Foucault's pendulum does that. And the ring laser gyroscope. Thanks, Bob.
Are we going to go to Bob? Bob never showed any of his data anyway, so we won't go with Bob. And I've looked at a couple other ones, and I can't find any data on any. They just make a statement that it does.
Yeah.
I literally look for their actual papers and stuff. And they actually give me sites to go to, and I can't find them. This buried under I don't know what. Yep. I dare you to look for the same yourself.
No, yeah, it's weird. Like it's hard looking for things like when things open and close too. I mean, citations are hard to find, and it took me a while to find some of mine too.
Mm-hmm. Okay, then we got Glenn Sell. She says, "What's the temperature inside of the vacuum?" I think it was for that demonstration you presented.
Yeah, don't know, but we could. I don't even know if you can have a temperature inside of a vacuum because you're measuring the particles, the movement of the particles. So I don't really know the answer to that, but if there was one, they varied it to account for that, right? We can weigh two masses in a vacuum right next to each other at the same temperature, and they will at the same density, and they will be different forces depending on how much mass is in there.
And they do way more in a vacuum, don't they? Strange.
Yep. Well, yeah, because the buoyancy is gone. Just to your point, Archimedes, the buoyancy is gone.
Exactly.
Then Glenn tells again, he says, Wesley, without mass, what is gravity?
Mass attracting mass.
No, he said without mass.
You say mass or math?
Without mass.
Mass.
Is that what he asked?
Without mass.
Yeah.
Mass. Without mass, yeah, you wouldn't have gravity.
So the second part is, what is gravity without mass?
Nothing. It doesn't exist without mass. It would be zero. The force of it would be zero because it only applies when masses are available.
We still haven't got to the monkey itself, have we?
And then some ask, how much does air weigh, Wesley, and how do we weigh it?
We may weigh air by pressure. I think, did we ask him? Yeah, I think we did ask him. We asked him what the PSI, what the P was, and he said pressure, which is kind of funny because pressure is measured in one way of PSI. I think we asked him a couple weeks ago what the P was, and he wasn't sure of it. So the P in PSI is pounds, which is the force. So the weight is not measured at one single point. It's measured across the surface area, and that's where you get pressure.
So it's an average of pounds of pressure per square inch.
Exactly.
But
you could do that. You could do that with yourself, right? You stand on a scale, get your if you can get your pounds of force, and then you figure out how, if you're standing on your feet, how many inches squared your feet are, and then you can actually get a PSI for yourself if you want.
Yeah. So, but the thing is, how do you weigh air?
You weigh it with a pressure gauge.
You do? That's
or
how you weigh it?
You know what you could also do is you could calibrate a scale in a vacuum and then take it out of that vacuum, and then you would get what the pressure is outside.
Mm-hmm. Yeah, it makes sense. Yeah. So what are the causes of pressure? That's the question.
Yeah. It's gravity.
It is. Okay. So I can give you citations that show that pressure is caused by containment. So
okay,
that's absolute.
Yeah, there's many things that can cause pressure other than gravity, but the atmosphere is caused, again, in my model by gravity, and we can calculate it, right? We can predict it.
Well, you can't get the full surface area of a container this large, could you?
Okay, so how do you what do you use to calculate the pressure of air? What formula do you use?
I'm not looking at a formula. I'm looking at a cause. That's what I said.
Okay, so you can't calculate it.
Yeah, calculations aren't cause.
No, I know, but in science, you know what we do? We make predictions, and then we make a prediction and see if that's right, because then that's how we validate that, and that's what I've yet to see for RDD.
So I would love to see that for you guys for the whole mass of the Earth. I would love to see the solid pressure across and how you came to the conclusion that the cause of it.
Sure. We can measure the cause by doing Cavendish.
Two completely different things.
Okay, cool.
Gas is not inherently subject to gravity.
Okay, citation, please.
No gas law includes gravity in it. Dude, none of the. It's not a citation. Those are laws, and laws aren't experiments.
Well,
those are absolute.
Your own citation used it in Archimedes' principle.
That's Archimedes' principle. No, he didn't use it in demonstrating the displacement at all.
That's what was at the end of the video. The G.
That's his opinion. I just demonstrated his displacement.
But you used it, right?
Well, just the part of the video, yes.
Okay. Yeah, it's fair.
I didn't use this whole video. That's not my claim.
Okay.
Okay, let's move on to the next one. Jesus already returned says, how did 315 million cubic miles of water appear upon a spinning sphere without a vacuum? That would boil any H2O before it could even rain upon the world.
That's a good cosmological discussion and debate. I think it started out. I think our planet the mainstream science would say that it started out as a gas giant, so the gas was already here. The gas pressure was already here, but I would defer to people smarter to me on that topic.
So it's not necessarily your claim. You're going, it's the mainstream's claim. So you don't believe that the planet was formed the way they postulated?
Oh, so you came to all these things that we're talking about on your own without appealing to anybody else?
I didn't appeal to anything. No.
Oh,
I just
you didn't for both of your sessions. You didn't go to a YouTube video.
Well, it's not about going to a YouTube video. I don't really care what people believe.
Oh, then why did you present it?
Yeah.
If it was your claim, why did you present his claim?
I didn't present his claim. I just presented a demonstration he did. That's all.
Okay.
Okay, next one from Sogs. Wesley, if gravity is a force or a pseudo force, if not a force, then problem with Newton.
No. Okay. So he further refined it. Newton didn't understand why mass attracts mass. Einstein further refined it to explain why mass attracts mass. And so you could go a step further. Why does mass bend space-time? I don't think we have a clear answer on that. We can always go further. It's the expression, turtles all the way down. We can always explain further. Well, I think we can. Or at least that's what sciences predict. So Newton saw that mass attract mass. We see that, we observe that. And then Newton explained why we see mass attracting mass through relativity, the warping and bending of space-time. Why does mass warp and bend space-time? I don't know if that question has been answered yet. So yes, we can always go further. That's a really good point, but not understanding the first, what we see observationally, you wouldn't be able to get to the next observation.
I think it's out of the purview of science. It's astronomy, right?
Astronomy is science, part of the natural sciences.
So what a scientific experiment have you done to prove anything on the astrological level?
Okay, I haven't done any. What science experiment have you done?
None. I've never seen one. That's
Okay.
why I don't conflate the two.
Well, then why do you use RDD if you haven't done an experiment?
Because you can actually use it here in Ontario.
Well, have you done it?
Yeah, I've put a boat in the water, man.
Okay.
Yeah,
Cool.
I mean, literally, I've actually traveled in an airplane.
That's an experiment?
Well, not necessarily experiment. These are sciences. These are fields that I thought was technology is a better way to.
So I guess I don't understand when you
natural sciences are a natural phenomenon that you can observe and you can actually find the cause and effect of. That's
so
what
you asked me what experiments I have personally done in astronomy, as if that would invalidate my. Wait, hold on. Let me finish. You've asked me what experiments I have done to validate astronomy or do a science experiment. So would it not be fair for me to turn that on to you? What experiments have you done to validate RDD?
I have. I've done a few, and when I was in grade school, man, I'm sure we all have.
Okay, what did you manipulate? What variable did you manipulate, and what were you measuring?
Well, we're just measuring the density of an object due to the density of its medium. That's it.
You're measuring the density of the object due to the density of the medium. That's what you just said. Do you want to clarify?
Well, I'm just saying, like, took an object like Anthony's experiment. We did that in grade school. The egg, salt.
So what did you manipulate?
I can't speak.
It's okay.
We manipulated the density of the medium due to the.
And what did you measure? What was the outcome?
We actually got it to float.
So what is that a measurement of? What's the IVDV?
Well, I don't know if there was an IV, or it's really a simple one. It's it's the object, the weight of the object, it changed due to the actual density of the medium.
Flatsoid, I just want to have an idea. I don't have a time crunch, but how many more questions do you have so far? Just so I know.
Yeah, I'm stopping all the questions at the moment. It's like, I think 5 left.
Okay, great.
Yeah.
So we'll only take super chat questions if it really comes up. But yeah, let's try and get to the last. I think it's like 5 or 6. Okay. How does Eddington experiment manipulate the temperature and pressure of outer space? That's by Glenn.
Yeah. So that remains pretty much constant, the surface of the sun and the surface of the outer space. So those are held constant for before and after the experiment.
Awesome.
I got a
you have
question.
nothing
for
to
you.
say, Roger?
How did you determine the surface of the sun, man? What validation do you have for that?
We can measure it, and we can also measure how heat affects light.
On a scale, how did you measure it? I mean, how was this done?
So we can measure how we can increase heat and see that light doesn't bend.
Heat and light. Okay.
Yep. Do you think heat causes light to bend?
Actually, it causes the medium to bend.
Oh, heat causes mediums to bend. Is that what you're saying?
No, you can demonstrate this with a mirage, dude.
Okay, cool.
Okay, next question. By Sov, wasn't Earth's gravity formulated from its radius value, Wesley?
Say that one more time. I'm trying to follow.
Wasn't Earth's gravity formulated from its radius value?
No. Gravity has nothing to do with the radius of the Earth. Now, if you want to say the effects, the force of gravity on the surface of Earth depends on the radius, then sure. But we don't need that. We could do experiments further out. The Cavendish doesn't rely on the radius of Earth at all. So we can do different experiments that don't take into the radius of Earth.
Okay. Nothing, Roger?
How did Cavendish, what in the Cavendish experiment had anything to do with the radius of the Earth to begin with?
Exactly. Good point. Thanks for helping me with Sov's question.
Well, no, but the question is, I thought it was the density of the Earth.
Nope, that's not what he asked.
No,
Well,
the
I'm just
question
saying,
was about the radius.
the radius, but I mean, in order to get a density value, you'd have to have the size of the Earth, right?
Yeah, we're not talking about the density of the Earth.
Well, I think Saab is just making a point as how you came to the mean density. It does include the radius value.
He never mentioned the word density, so I'm not. If you want to ask me that question, you're perfectly fine.
Sure, yeah, I'm asking you, how did they contrive the density of the Earth due with its radius?
Sure. So density is mass per unit volume. And so we know the volume of the Earth and we know the mass of the Earth. So you can calculate it that way.
How was this measured?
Which one?
The radius of the Earth.
Many different ways. You know the answer to this. Come on, man.
Yeah, right? I know, but I'm asking you.
Cool.
You're the expert here, so.
No, I'm not an expert, but Eratosthenes measured it. We can use it measuring angles to the stars. There's many ways that we can measure it. We use satellites nowadays and GPS.
Huh. Okay.
Okay. Let's move on to the next one. Okay. Then Sol says as well, Wesley, can you cite or show the experiment that verifies that gas behavior is affected by gravity?
Yes. So that's actually fairly easy to do. Again, remember Sav, we talked about this. PSI is pounds, not pressure per square inch. Pressure is pounds per square inch. And so what we do is we measure pressure per square inch, or sorry, I used your term, pounds per square inch on the surface of the Earth. And as we get higher and higher up, that pressure goes down. And so we measure the effects of gravity on gas.
Okay. So there's no effect from temperature on gas, which is actually more validatable than gravity.
Did I say that? Did I say that?
Yeah. How did you vary the gravity in the middle of all that?
How do I vary the gravity? No dirt in the middle?
Yeah.
Okay.
How do you validate gravity when you're actually varying the temperatures, and they do vary as you go higher?
Yeah, that's actually a really good question. We can vary gravity like in the Cavendish by changing the mass. We can vary gravity by going to the moon. We can go to different planets to do it. We can also vary the strength of gravity by going higher up. because the strength of gravity, the force, goes down as you go up.
So you have valid citations how where you could actually show you've been to other planets and to the moon, for example.
Again, you think I have to go to other planets?
Oh no, but you're reciting it. So,
but you cited this guy on YouTube for your whole presentation. You didn't do it.
I didn't cite him. I used him for a demonstration.
Right, for your whole argument, kind of.
That's not my whole argument. That's just I just showed displacement.
That's fair. My opinion, if you want my opinion, you don't have to do the experiment yourself. You have to look at other experiments and see how much they've been done, look at the evidence from them. So in my worldview, you don't have to do all the experiments yourself. You should do some, and I have, but you don't have to do all of them. Otherwise, we would never progress. I mean, we'd be stuck in the Stone Ages if we didn't build upon those that came before us.
What part of the Stone Ages are you going with here? I mean, I don't think we've ever been in the Stone Ages personally.
Okay. Well, this is my worldview. If you want to discuss yours, that's perfectly fine.
Yeah. Okay. On to the next one. From Sav, he says, "Are you suggesting inherent perpetual energy, even though it violates the laws of thermodynamics?"
Nope. Again, maybe you didn't hear me quite, but all forces don't require energy. So just like a permanent magnet, all forces don't require perpetual energy.
Well, I can tell you as rebuttal to that, there is no such thing as a solid permanent magnet. They do, or everything in the known world and universe, or you would call it, are subject to entropic law.
Yes. So nothing is perfect, right? I would agree with you there, but permanent magnets, if you keep them super cooled, they won't lose their magnetism. So
in your world view or your scientific view, you might say, how long has the universe been going?
I don't know offhand.
It wouldn't have already dissipated.
Is that what you think?
In your model? Your model is, I think, it's 43 billion years.
43 billion years old. Okay. Well, I'm just going to leave that as it stands. But no, I don't believe the universe is 43 billion years old. But
if you're going to stick with your precise scientific model, that's what they predict. As you say, where we'd be at now. Yeah. So, those predictions are way off, obviously. So,
hey, Roger, I am 100% in agree with you that the universe is not 43 billion years old. So we found some common ground there.
We can go out. Let's go ahead.
On the last three questions, guys.
All right.
Jesus already returned. Says, Wes, do you really believe in parachutes within a Martian sky heaven?
Say that last part. Parachutes with what?
In Martian
parachutes within a Martian sky heaven. I think he says, do you believe there are parachutes on Mars?
For the rover that went there, I don't know if they used parachutes, but if they did, and they have evidence of it, sure. But that would be if we sent the rover that was sent there. I don't know if they use parachutes, but I can look into that.
Awesome. Thank you. And
I can reassure you that they did, Wesley. But we got evidence that might lean toward the fact that they didn't go to Mars.
Cool. We should do another debate, and you can present your evidence.
Oh, well, yeah, sure, not a problem, man.
There's many debates you can still have.
Yeah, this could go on to infinity, you might say.
Yeah.
Nice. 43 billion years, right, Roger? We can do it for the next 43 billion years.
I don't think I'll make it that long, dude. I promise you.
All right, cool.
We'll just give you the your youth potion elixir again.
Dude, your screen, that screen image that you had for the thumbnail, I had to do a double take on that.
Yeah, the thing is, like, Rhonda has most of like recent pictures of me that are worth putting on there, and she wasn't here when he actually texted me. I had to go dig through like an archive of photos, and I mean, some of them, I don't think were appropriate for this. Like, a lot of them are from my party days. So. And you had those, didn't you, Wesley? You went to college, of course you did.
Yep.
Yeah.
Okay.
Not to say that we're condoning any of those activities, ladies and gentlemen.
Okay. Bendy Horizon says, Wesley, why my question was so hard for him? Why do they avoid at all costs showing physical demonstrations of globe claims instead of deferring to and instead defer to unprovable theories, etc.
Did he? What? Do you remember what he asked first? Was that the curvature of the Earth?
Let me go back up to one of these old.
So I'll just answer that generic.
Curve of the alleged spinner.
Okay.
Yeah,
I don't know what you're talking about, bendy spacetime, because I don't claim, or I'm not aware of that the spin of the Earth is curving. I don't even know what that would actually mean. Like, what does it mean to curve a spinny ball? Unless you're talking about orbits. I do believe that the planet orbits, and there's evidence. So what I do is I go with the most evidence. Could I be wrong? Sure. But it's very unlikely if I go with the amount of evidence one on one side versus the other side. So that's what I try to do. Do I get it perfect? No. But yeah.
Well, who owns most of the observatories and most of the science institutions now as it is? So it's definitely going to be biased towards what the view is, what they're trying to prove. Like, I'll give you like LIGO, for instance. They've been running that thing for how long? I'm still waiting for gravitational waves.
Okay. So who owns most of the universities and telescope observatories?
The Catholic Church, actually, and most of the science institutions are run by governments. They're not.
Right.
They're not in there for independent research and stuff. And most of the independent theories that are put out there by physicists are usually not touted at all in mainstream science. And they do have some validation to a few of them that I've seen, but they don't get consensus.
Okay. Why do you believe that most of them are owned by Catholic foundations?
Well, they are. You can, or government or Catholic. That's usually the people who run most of the observatories.
No, what I'm asking for is what is your evidence for that? Did you look it up and look at who owns them?
I've looked at them. Yeah, I've looked at a lot of telescopes.
All right. Yeah. If you could post that in the chat once we're done, or just tag me on it, like, I'd love to see that. That'd be awesome. But that's another good debate for later.
Yes, we could actually do that on another time. I'll have to go gather them all up.
Perfect. Awesome.
I've done a couple of shows on their telescopes and where they are and who owns them.
Cool.
Awesome. Thank you very much. And now we're on the last question by Dick Wayne, your favorite person. Wesley.
There you go.
When was Earth just a ball of gas?
I don't know the answer to that. I would defer to some other good scientists who are probably in the chat, or Dick Wayne has definitely talked to a few of them. So I don't know the answer to that, and that's fine. Before Roger responds, I just have a request. I see Neil Constantino in chat. Buck Sodbuster has been asking to debate. So if you ever want to agree on debate, I'm sure that Flatzoid would be happy to host you guys or somebody else. So Neil, if you want to do that. But to get back to the question, I don't know at what point that started and what point it became solid. I don't know that, but that's something that if I was interested, I would research it. So I hope you do that, Dick.
Awesome. Well, that was great. I really appreciate you guys coming on.
Yeah.
I hope you guys enjoyed that as much as I did. It was nice and cordial.
Yep.
And I would love to see those other debates and other topics you guys want to talk about. And I'm sure Wesley and Roger, you guys are more than happy to debate other people too. So.
Yeah, I open invitation. There's some topics that I'm not great at, so I'll leave that to other people and have recommendations. But if you're ever interested, I'm usually in Flatzoid's panel, so you can always ask me or hit up Flatzoid. So I appreciate it. Thanks for having me, Roger. Really good, really well done. Thanks for discussing this with me. Appreciate it.
I'll say the same for Zoe. You actually put together a PowerPoint presentation.
Yeah, some of my friends were making fun of me because it was PowerPoint and not a Google deck. They say I'm stuck in the 1990s, but I am.
Nothing wrong with that at all, man.
Thank you for sticking up for me, Roger. I think that will mean a lot for them. So, thanks, Flatzoid. Good job moderating.
Yeah, this was enjoyable. It wasn't a visceral debate at all.
Yeah. All right, see you guys.
Cool. Thanks for coming, man.
Yep.
Okay, so we'll be doing an after show now. I've still got about 40% battery life, so we can still go on for maybe another half an hour or something. Oh, cool. I'm going to stick the link in. And then if you guys have anything you want to come in and have a discussion and say what your thoughts are, this is your chance. There we go. The link is attached. And thank you guys for everybody that did send send in super chats and everything, and all the questions. I really appreciate it. It was good to get so much questions in. What are your thoughts, Roger?
Well, I can tell you one thing: that Neil's not going to debate anybody. Neil doesn't do debates, so I've never seen him in a debate. He's been on a flat Earth debate. I would love to see Neil debate Buck Sidebuster, but Buck Sidebuster. Hey, D-Man.
Yeah, I think I'd enjoy it too. But yeah, I'm also happy to debate. Hey, PJ, what's up, D-Man? Good to you guys. What do you guys think of the show, of the debate?
It was good. It was good. I do think it was turned out a decent debate. I think that Roger's video played a little too long without talking about it. And straight afterwards, he kind of didn't talk about the video straight away. But apart from that, I thought the debate was good, man. It was a good debate.
I'll take that into the notes. I'll
But no, the video you showed, I understand why the video was showing 100%.
Yeah.
I mean, I'm not a debater, bro. You're getting advice from a guy that doesn't debate. You know what I mean? This is just my opinion.
Yeah, you know? The thing is that I never saw any of the other variables they keep talking about with gravity. That was never demonstrated at all. Yeah. That would account for a lot of the effects that they showed that claim that it is gravity.
Yeah.
I mean,
hey, Glenn, good to see you, bro.
It's just it's unnecessary.
Hey guys,
it's adding unnecessary layers onto something that don't need to be added.
No,
and
there's
they
nothing
need that
about a vacuum chamber. Is there, guys? Go ahead.
They basically need that for them to have their magical balls, and that's basically what that comes down to. Take away the ball, and it's the gravity. This gravity idea doesn't need. You can just simply go right back to density and buoyancy in the medium. It's just that simple.
Yeah, that was kind of my point to my demonstration.
That's it. I mean, it's unnecessary. It's unneeded. Yeah. So, I mean, you could take measurements of buoyancy and density doing its thing and displacement just the same. Why add all this extra fantasy land stuff to it?
Well, they got to have the astronomy part of it too. I never got the scientific experiment with that either.
Yeah, the thing is, that Buck's sitting there glazing you flats for being a good moderator, but yet he's sitting there arguing with Neil and telling him how much I don't know, sycophant towards Nathan and all that. People are. He's an idiot.
Yeah, he's been on SED and things. Okay, so but I mean, he can always go debate him on SED. But exactly. I'm saying I'm more than happy to host a debate show. But if Neil doesn't want to accept, what can we do? Like I said, I'm more than happy to debate him too. But what's up, Sal?
What's going on? He didn't answer my question.
No,
he didn't answer my question at all. Just telling me, well, yeah, we have a gradient. It's like, look, show the experiment proving that gravity has any effect on gas behavior. He said, well, you have a mass of air. Okay, how much does air weigh? It can't be the source of its own pressure. Yeah. Air cannot be the source of its own pressure. I'm sorry. That just doesn't fly.
No, not even in NASA citations they'll say that either.
Well, the thing is, I don't know if you guys realize, but this is usually all the globies do, though. They don't actually have demonstrations. They have, what can you say, beliefs based on what they claim to be experiments that aren't actually experimental in the first place. I was hoping you were going to bring that up, Roger, by telling him like Cavendish isn't even an experiment.
No.
But
I wanted to refer him to like my channel to a point, but I shouldn't have done that. Next time I'll bring some of the janky experiments, the videos of Cavendish failing. That would be probably a better way to do it, wouldn't it?
Well, that's the thing. An experiment is not only have to be repeatable, but the results have to be consistent.
Yep.
Consistent results. These aren't consistent results. You've got a thing, it's off balance and it moved. Oh, wow. How about that? What a strange thing. You know, does that prove mass attracts mass? Not a freaking bit. And then when I asked where he got the R value, wow, what a disaster that was. Because if Cavendish was trying to figure the mass or the mean density of the Earth, he would have to know how big it was.
Right?
Yeah. Well, I did put that to him, didn't I? Didn't I ask him that question?
Yeah.
You'd have to know how big it was. I mean, criminy, man.
I want to ask, why has
you also got to know how what everything in the center of it's made of?
Right, all the materials.
Yes.
Exactly.
Yeah.
I mean, exactly. You've no idea what's meant to be in the blooming middle of it. So how the heck?
Well, they pre-assumed it. They didn't experiment on it. They pre-assumed what's in the middle of it.
Yeah.
Sure. I mean, for all he knows, there's a big, huge hole in the middle of the earth. It's just full of air or nothing for that
What if
matter.
it's cork? Yeah, what if it's cork? But have you guys realized that the so-called anything experiment that they cite, first of all, had false results? They actually literally had to make up results to make it fit what they want, and it's never been replicated because it's not an experiment.
He excluded any data that didn't conform to his hypothesis too.
Exactly.
Well, they do that on a regular. I've talked to guys on Discord, and they'll literally say they have to do like 150 to 200 Cavendishes to get to the result they're looking for. Like literally,
Vicky.
it's a fact. Yeah,
Vicky, I like that. Vicky says that they're consistently inconsistent. And I'm like, yeah, exactly. Exactly. And
Well,
it's like, and then there's this talk about a ball of gas. I just laughed my ass off. How the hell are you going to get a ball of gas?
Well, you got to have Einstein to put together an equation.
How?
I don't know,
You
man.
can't. It's like having a ball of water. How are you going to get a ball of water?
Unless you freeze the bugger in that shape, and you would have to have a container to freeze it in to get it to that shape.
And listen, when you're in a so-called weightless environment and it wants to come together like that, that's just due to the pressure forming inward on that water because of the displacement from all directions. That's all.
Right.
Where's your pressure forming that in space? You don't have that.
No, you don't.
You can't have a ball of gas. That's just stupid.
It's hard to have a ball of water, let alone you can't have any of it. It'll turn into a ball of gas, or not a ball of gas, but it'll turn into gas. It'll gas out.
Can you lay one block of water on top of another?
Right.
No. Yeah. Hey, that'd be an experiment, PJ. See if you could do it.
Yeah.
I think. Let me tell you. I got to tell you what I think was beautiful. He wants to get after me. This is the only thing he can ever bring up is, he said it was pounds. We were talking about pressure, and or that it's pressure. The P in PSI was pressure when it's pounds. We were talking about that, and I misspoke and said pounds or said pressure.
Yeah.
And then he turned around and did the exact same damn thing. So I don't even want to hear his mouth anymore on that shit. I don't even want to hear his mouth on that.
Are you going to unban him now? That he's such a nice guy.
No, I'm not going to unban him. His big Jay Leno jaw take up half the freaking screen. I don't want him up here.
That's exactly the thing. Is like Wesley can be okay, but it's his entourage. It's the people he brings in with him. They're all women trolls, all of them.
Most of them are from. I hate to say it's Mike's channel. They come over here.
They're looking for. Buck me be persistent, but the fact that he makes umpteen sock accounts when he gets banned just shows that he's trollish. He doesn't accept his banning, so he goes to make more sock accounts. That's about 10 of them.
Can I jump in here just for a second?
Sure.
PSI is rated as pounds per square inch, is a unit of pressure commonly used in the United States and other countries that use the imperial system. 1 PSI is defined as the pressure resulting from a force of 1 pound force applied to an area of 1 square inch. That's PSI.
That's
so
what it says, pounds per square inch.
Yeah.
I think they only
gravity per square inch.
A measurement, and there's no gravity in it. What are you talking about?
So not gravity per square inch. Okay.
Oh, yeah.
Can you stop using my missus picture? What a bunch of idiots. Just to go and use get a grip. No, Vicky's already banned it, but get a grip. Use your own picture.
Who's using Vicky's picture?
You can call yourself Vicky if you want, whatever dude you are, but don't use a picture. You know what I mean? Call yourself Vicky if that's what you fancy, but just don't use a picture because I ain't with you, dude.
They're still going on about puppy dogs. Jesus. Sorry. I didn't mean to use that word. I apologize. It's annoying when they keep going to the same thing. That's all they keep ad hom. They're not attacking the argument, they're attacking you and me and everybody else in this genre.
Well, of course, it's weird and mixed up, Bendy Horizon. I remember the first time they did it, they took a picture and put black eyes on her and tried to say that I beat her up and stuff. You know what I mean?
Well, it didn't do as bad as Peg Slapper.
Ugh. Yeah, that was terrible.
I mean, it's just classic
He
Wesley.
denies that was him. He denies that was him.
That was just classic Wesley. That's what you'll get from Wesley every time.
Oh, really? Oh, really?
Really?
D-man? Really? Is that how
Really?
you're going? Is that what you're going to do?
You know, he's just going to repeat the same thing because they're all repeaters. They need that crap, and they have to make it overly complicated because they need it for the globe itself. When you remove the globe itself, then gravity is not needed. It just simply becomes RDD or a buoyancy density through a medium. It's just that simple. They need it for that model. It's not needed for this, for what we live in. It's needed for their fantasy model.
And the parachutes do work on Mars.
But I mean,
Parachutes on Mars.
It always comes back down to, yeah, we can make predictions using gravity. No, use predictions based on calculations that you're assuming is caused by gravity. That doesn't mean gravity causes it.
Yeah.
Just because I can predict this scissors falls at 9.8 meters per second in a vacuum doesn't mean gravity caused it. Just because you call that acceleration due to gravity doesn't make it.
Right. It doesn't mean that
Exactly.
that's what caused it.
Yeah.
You prove that that's what caused it. Prove that the weight is due to gravity.
Yeah.
You know, because I can change the medium and I change the weight.
Yep.
It's that simple. There's never an instance where something is not subject to a fluid medium, ever. And this myth about a vacuum chamber, it's not an absence of medium. It's just a very thinning of medium. All you've got is a very low pressure system. That's all. And guess what? It requires containment.
The whole thing does.
God, I don't know how they get this idea, air fall down, go boom, boom. No, it doesn't ever do that at all.
Yeah, I was waiting for him to cite the experiment where they actually prove gravity has an effect on gases.
Well, there isn't one.
There isn't one. It doesn't exist.
I said it goes in all directions, and he said its direction. This is the direction of gravity is down, right? Supposedly,
Right?
Yeah, gases don't go up at all.
Well,
Ever.
in their model,
Water vapor. I think it's funny how the clouds stop at 12 miles. It hits like a wall and it'll flatten out. Like gravity, I ain't gonna let you go more than 12 miles. That's it.
Right.
Where does
And
the gravitation
the
stop?
PSI that you feel is not due to the weight of the air. It's due to the displacement of a confined fluid. If it was not confined, it would offer no resistance and there would be no pressure.
that's right.
It's that simple. You are displacing the medium. That's
You have to
all
have-
there is.
You have to have a
When-
surface to get a pressure anyway. In all
When
directions.
you do anything, you are displacing. When you walk
Right.
when you walk out, you move, you're displacing. When you fall, you're displacing. When you rise, you're displacing. When you drive, you're displacing. You're displacing everything because
time.
there is a system with pressure and containment.
Right.
Even
Without
if-
containment, you would have no pressure.
Even
Right.
sitting there motionless, you're displacing. You know what I mean? It's-
So like the example with the little ball with the coins in it, it displaces the water faster. That's why it goes
Yeah,
down.
it's simply heavier. It's just got more weight to it, so it's naturally gonna.
Where's the gravity in
bypass.
that equation? Yeah.
It's naturally just bypassing it through bypassing the medium.
Right.
So naturally, if there was no coins in it, what would it do? It would float. And if you just added more weight into it until it bypassed what the fluid could hold, well, it would just drop like a rock. It would keep on going until it met its equal, and then it would stop dropping, or it would just keep on going.
To the
Well,
equilibrium.
it's like if you increase the density of the medium, soon the medium will, at a point, the medium will now displace the object.
Yeah.
Okay.
They rate that with the viscosity.
You either
right?
displace the medium or the medium displaces the object. It's just a ratio. It's just a ratio, a balance again.
yeah.
I noticed he didn't go into specific gravity. He didn't break out the equations to go with it because they actually use that same exact equation, the density to the medium. And that's what it is. That's how they actually figure it out. Yeah.
The other thing too is I think do you think that they need that gravity crap to kind of, because in their model the gravity is always pointing towards the ground, gravity is always going towards the ground, that they need that to explain that gravity is now going towards the ground on the bottom of the globe, and now it needs to go up.
Yeah. Yes. Yeah.
Yeah.
And that's what I think it is. I think that's why they need that gravity hocus pocus, because how would they explain something going up from the bottom? So,
Exactly.
I mean, when you think about it, you're on top of something flat. Yeah, of course something's going to drop down, but how do you explain it going up from the bottom?
To me, that's not a downward bias. Like you say, things go up also.
When Neil pointed out that
it's equilibrium, I think. I mean,
in order to so-called measure their gravity, they need a flat plane to begin with.
Yeah. Right.
What about the sun during the day? Shouldn't I be lighter?
Oh, yeah.
You know, at noon I'm the lightest,
Yeah.
and at midnight I'm the heaviest because I'm completely being pulled by the sun and the earth. You know, at midnight, because the sun's there and the earth and all this gravity pulling on me, and then when I'm around here at noontime, right, I've got the sun pulling on me, and not and it should be making me lighter, right?
Yeah. Yeah.
I'd say the same with a full moon. You'd be lighter on a full moon, wouldn't you?
Well, you weigh yourself right now and weigh yourself tonight at midnight.
Right. see if it changes. It should. It should.
I seriously doubt it will.
It'll be negligible. It's negligible.
It's just the dumbest idea. I mean, wow. It's the whole thing is that you have to have this mythical gravity in order to have your solar system and your planets and all this other nonsense. But then when it comes right down to the fundamentals of it, you know, Cece, shut up. When it comes right down to the fundamentals of it, it's like, you know, you want to start talking about balls of gas in a vacuum. How the hell does that happen? How in the world does a mass of any gases or any fluid for that matter be obtained without some kind of physical containment?
Yeah, coalesce into a ball in a vacuum is just impossible.
Give me an idea there. With you hollering there, the sound wave that you hollered at CC with, was it pulled down by gravity?
It should have been. It should have been. It reached the ground. It was louder at the ground than it was up to the ground. Yeah, Jesus, I know.
He said that you actually get lighter as you go up.
That's not true.
And that's not true, because we watched a ton of videos of them showing the vacuum making things heavier in that environment as you start to travel up, not the opposite.
As soon as you start to reduce the pressure, the weight starts to increase.
Well, that's why I laughed when he brought up critical think, and he is not an experimenter. He's learning, doesn't need to account for any variables or anything. Remember?
Yeah, I remember the debate you had with him too. He didn't really
calibrate anything. Don't need to calibrate anything. Don't need to worry about any variables. It's like, what?
Oh, I think they're getting ready to bring out the big one, the TFE documentary, because everybody, like Jonathan Morandi was on Mark Sargent's promoting it, I think, last night. So,
well, as soon as that comes up, I'll be reviewing it on Rumble.
Do it on YouTube. Duffy was
everybody looking in the goddamn sky all the time, looking in the dang sky all the time. The Earth is a globe. How do you know that? Because I looked up at the sky. Okay,
yeah. Makes sense, doesn't it?
Fantasy.
I did that. I did that to my boss the other day just to fuck with him. He goes, check and see if that he says, check and make sure that countertop stayed level as that glue on it dried and everything. Okay. And so I walked over there with the level and I looked up at the ceiling. And he goes, what are you doing? I says, I'm a glober.
Let me look at the light.
Yeah. When he said, how do you measure the curvature? We were like, 60 degrees per mile or something? Or
is it 1 degree every 69 miles?
69 miles. Well, they go to 60 to 69. It varies on who you're talking to.
And what does that degree equate to in an actual physical measurement? So, you know, can you tell me that? You know, I know it doesn't sound very consequential. 1 degree, 69 miles. What does that equate to? How many inches per mile would that be?
Well, it depends on the scale what you're measuring too. Actually, you don't have a hypotenuse there, anyways. They don't have the height of those objects. They claim they do. But, they don't even use them in practical use, even when they're doing navigation anywhere. They can't. They're all assumed.
Oh man.
Classic Wesley.
Oh really, D-man?
If
Really?
you've talked to him once, you've talked to him 1,000 times.
Yeah.
It doesn't change.
He got to the point where my comments on the video and people in the chat were like, don't ever let him on here ever again.
Yeah.
I was like, sorry, man, it's out of my hands, brother. Totally out of my hands.
Name
You
on
could-
my
you-
channel. They don't want them on.
You could add some people to that list, I can tell you now.
Oh
Some
my
others.
God. What was it? We had the Three Stooges up there the other night. What did we have? We had IC Spin, we had Monkey Cat and Wesley there for a short period of time with his stock account. And I says, you're damn lucky to even be here, buddy. In fact, I really don't like you. And I just kicked him.
Yeah, you're running from Saab. That's what he told me in one of the emails.
Oh,
Saab's
yeah.
running from me, and he
Sure.
won't debate.
Yeah. You scared, Saab? You scared?
I've
really?
already debated him and he lost. I already debated him and he lost miserably.
Well, my reply to
Miserably,
him
because
was
he could not meet the burden of proof that his position imposes upon him.
Yeah, I told him you debated McToon and Craig both, and you've dealt with this topic with him
Oh,
over and over. And you're just tired of it, man. I am too.
Just show me a picture of Gravity, Craig. Good God.
Where's it at? It's right behind you, Saab.
It's all around you.
I mean, that's just some of the dumbest shit. And it's like, wait a second, take your head out of the space and shit. Try to, think like a grown up here. Okay. Get the Star Trek and all that dumb shit out of your head for a minute here. Let's look at reality. Okay. And these people, they all have these ambitions like, oh, I can't wait till we go to other planets and stuff. Well, you're going to have to, because that's never going to happen. And even if it did, think about this. Think about the longest flight you've ever taken. Okay. And how glad you were to get off that plane. That was only a few hours. Can you imagine being months or years cramped up in some little shit like that, drinking your recycled pee and eating God knows what they have for food to supply them with it for that period of time?
Sounds fun.
You know what I'm saying? And then you get to your destination. Let's just say it's Mars. Okay. And so now what do? You put on your little space suit and you go out there and you hop around and you look at some fucking rocks. You're not coming back. Okay. You don't have the capacity to come back. You go out there and bounce around and look at some rocks and everything. Day 57 goes by. Now what are we doing? What are we doing now on day 57? We're starting to get a little bored with the shit. Missing home. Wishing maybe we hadn't embarked on this, because this is where we're going to spend our life. And that's what you get to do, is eat recycled pee and poop. It's what are you? Come on, people. This isn't a science fiction story. This is the reality. This is what you would face if you actually were able to break free of the firmament, and that these wandering stars are actually balls of terra firma that you can land on. That's what you got. That's what you got. Hey, look at the progress of mankind. Hell, you could just go isolate yourself in the freaking desert and get that.
Drink your own poo.
No, thank you. They've scheduled Artemis for this year, they say. So we'll see what they're going to do with this one.
Again?
26, dude. Yeah.
It's scheduled it again?
Yeah, that's what they say. I'm waiting to see the itinerary. I'm waiting. I Space.gov sends me stuff all the time. So.
And we got that spaceship asteroid coming towards us. What's its name?
Atlas.
3i Atlas.
Yeah, that's the one. That's the one.
giant space dookie.
Yeah,
nobody's worried about it now.
There's a channel actually that follows that thing and definitely says it's a ship because it's too symmetrical and all that.
Whatever.
You know?
Have you seen NASA's photos of it? They're crap, dude. They're like grainy little white specks.
Yeah.
This wasn't even photos. This was lines. This was like a scan of some sort. You know.
I went out in the backyard and took a picture of the LED light that's on the shed outside in the fog, and it looked just like the 3i Atlas. And I was like, "Look, it's the 3i Atlas."
Nice.
It's actually the LED light on my shed.
So easily done, huh?
Yeah, so why do they take all this energy and effort to get to the moon or wherever we're going and invest it here, people? That's tons of millions of dollars that we can solve so many problems. Oh, wait a minute. They want the problems here. That's why they do all
exactly. There's no money in that doing that here, because what are they going to do after they've thrown everything that they've set away?
I don't know. It's a good question.
So there you go.
Yeah. Well, Trump can build another ballroom with some of that money, you know.
Well, you know what's going to happen. They're not going to be able to do it because of the expensive ass war that he just embarked on.
Oh, nice.
With Venezuela. Yes, we've gone in there and they, I guess, kidnapped the president of a sovereign country. I guess piracy wasn't enough.
Sweet.
So, I mean, wow. So they'll have to say, we're going to have to postpone the Artemis mission because of the war in Venezuela or the war in Iran or whatever the case may be. It always is. Vietnam was what was sucking up all the money from being able to do any more moon missions and everything else, supposedly. I mean, come on, y'all.
Hey, Ryan's here. Hey, Ryan, I'm sorry I haven't texted you back, man. I've been kind of like busy. He texted me today.
All good.
What's up, Dr. Ryan?
Doctor, yeah, he's got his lab coat on. See the whiteboard behind him? Yeah. He's gonna actually get an equation to prove the existence of gravity by manipulating the actual thing you're trying to find.
Oh man,
Yeah.
I'll tell you, it's stressful.
Well, you could call it giggities. I heard that. Let's call gravity giggities from now on.
All right, I'm down.
And he's got this thing where he goes, and I know he hates the word. And I said, I fucking hate a word. That's stupid. What do you mean hate a word? It's just, it seems to be your duct tape for everything. That's your duct tape for everything that you can't explain. Well, why does that happen? Well, because of gravity. Every time.
Well,
Because they need something universal to everything. Like it can't be magnetism. Because not everything's magnetic. It ain't how conductive or insulating. It's universal. We'll call it gravity. That's what everything has in common.
Yeah.
So we can apply it.
If you read back through the chat when I first came in, they were like, "Well, you can't just use the equation of density to predict things." I said, "Well, there's a lot more other variables out there than." So when you run into like a storm, where is gravity there? You're going to calculate for gravity for wind. And swells.
Well, I keep hearing about these predictions, Roger. What is it that we need to predict that is so tantamount to this whole thing? Where they're always talking about we can predict things. Well, what things do you predict? What is it actually that you predict? How fast something's going to fall to the ground? How often do you need to do that? And once you've already done it, then why would you need to do it again?
Well, if you're dropping bombs on things, yeah, you probably have to predict how fast they fall.
Well, they've already done that.
Okay.
So they have tables. So nobody's having to predict anything.
There you go.
So you think there's somebody up there in a bomber going, let's see now, the bombs weigh such and such, and we're traveling at this speed, and he's got his little calculator and his pen and paper out or nothing. No, man. They've got instruments that do that, man.
Yeah, and aerodynamics play a lot into that factor because you're moving at a speed. So they make bombs aerodynamic, not due to gravity, it's due to wind resistance and the speed you're going.
They're shaped a particular way to fall consistently so that it's so that they can consistently say, okay, well, this weighs this much, it falls at this rate, the nose tips at this angle, and they can figure it out.
So aerodynamics, right?
Yes.
And wouldn't it be like hydrodynamics when it comes to like torpedoes and things like that?
Yes.
I bet those formulas are quite different too. Why? Oh, we have a different medium that we're dealing with.
Like I said, it was medium dependent. All this argument was because nothing in nature is why there's a vacuum chamber over there. We got to calculate for it,
right?
Or shoot.
They're manipulating the medium all the time to get exactly what they want, not actually doing it through the medium so that they could say, okay, well, here's what it does and here's the reason why. That's why I say it's just fantasy land shit every time they come up with it. It just goes off in fantasy.
Go build vacuum chambers and play with toys. Look, I can put it in a vacuum. It'll change everything. Quick. Well, how about Action Lab? I could have used him for not a citation, for a demonstration. I like the way, your citation, and they're like, go to 1055 in the video. I know what they were looking for. They're looking for when he starts equivocating gravity to weight.
Yeah. Like, he said the word. He said the word. See? He said the word. It's like, God. Wait due to, they'll put in there acceleration due to gravity, weight due to gravity. Well, prove that shit is due to gravity.
prove gravity.
Or that it's just the weight
Yeah.
falling through the medium. So it's so goofy that they have to do that and make it so it's this magical fantasy land stuff. I don't get. I understand it now.
They have a force, D-man. They have to have a force.
Yeah.
They can't get it through their freaking head that the only forces involved are the displacement rate. And displacement is a force. Moving a physical thing from one place to another requires a force.
Yeah.
Well, you know, the USGS, they actually have a gravity model for the Earth, and that's what they try to calculate their sphere into. That's part of it. So that's why they got to have that gravity.
If you're walking from a place to place, you're exhibiting force. If you're driving from a place, the engine is exhibiting a force. It's using something to push you or move you. I could sit in the wheelchair and never touch the wheels. Am I going to move? No, I have to apply force, whether it be through my hands, or an engine or an electric, it starts getting goofy at that point where you're like, okay, this is just goofy.
Yeah, he didn't want me to share that Aries failure video. He's like, well, another time. Like, it was off topic.
That's just going to bed, by the way. He's just got to let us talk here for a bit. And
cool.
Thanks, man.
I can't display anything personally. I would play that little thing, but nobody can share it in here now, can we? Flats is gone.
No, of course.
Yeah. I'll do a thing on my channel. It's interesting because it had a lot. They had to add ether into it to disqualify the motion of the Earth.
You said he's backstage, but what happened? Why do you?
Well, because you can only have 6 in at a time.
Well, I'll get up and go. Let him in now.
Well,
I think he's ending the stream anyway. I think he's ending the stream, but letting you talk.
Yeah. Okay.
I think he's going to end
What's that, Roger? They removed. They added. I thought they removed ether out of it altogether.
They had ether as the evidence for their non-motion.
Well, I've got a thing coming that's going to be a great demonstration of this.
Oh, cool.
Okay. And what it is, it's a toy. It's a toy. It literally is a toy. And what it is, it's a little bathysphere, basically. Okay, which is kind of like a thimble in the water. And it has these little claws on it. Now, it has air in it. And this bottle is completely full of water. Now, water cannot be compressed, but air can. So we've got 2 different mediums. We've got a small amount of air in the little bathysphere, and we've got this thing full to the brim with water in it, sealed. If I squeeze the bottle, the plastic bottle, that water will compress the air inside of the little bathysphere, and it will now not be buoyant, and it will drop down to the bottom. We made the air inside of the bathysphere denser in ratio to the water, and the bathysphere itself was no longer buoyant, so it drops down to the bottom. And at the same time, little claws will open up, and you can drop it down. You can release the pressure and lift it back up a little bit. You can hold it in one spot, then you take it to the bottom, and then when you release it, those little claws will close. There's little things down at the bottom you can pick up. Them claws close, and then you release it, and it zooms right back up to the top because there's no longer any compression on that air. And that air is now allowed to expand back, which gives the bathysphere buoyancy, and it goes back up to the top.
So where did the gravity go? Where's gravity in that?
Exactly.
Not at all.
Exactly.
The cause and effect are the density of the air in that experiment. Yeah.
It's real. It's going to be a really cool little demonstration.
Is this
I
a
do that
little
with
silver, man?
this thing here. This is what they call a hand boiler. And all it is, whoops. I've got this fluid inside of here, this purple liquid. And there's a tube that runs down to the bottom all the way. Okay. There's just a small amount of area between the bottom of this tube and the bottom of this flask right here. And this is sealed off from the rest of it. That tube leads up into this other globe. Now, what happens is I'll take my hand and put on this bottom globe, and just my heat from my hand will expand the air inside of here, and force that liquid to go up to the top.
Yep.
That's fluid dynamics 101.
There you go.
See that? Now,
That
if I
agrees.
take my hand off, the air will start to cool down here,
Yeah.
and it'll allow the liquid to come down. Now I can speed it up by heating the air in the top one.
Yeah.
See, now this is warmer now. This is warmer now right here. Okay. So watch what happens now. Watch how slow it goes when I put my hand on it this time. See it go up a lot slower.
Yeah.
Because it's waiting as this air cools, it makes room for the liquid to go in. There it is, finally.
There it is. That's a good little thing for a demonstration. It's pretty cool.
Yeah.
And the little Superman's going to be cool too when you get.
I think they're like $6 on Amazon.
Nice.
I can go to like a hobby store like here, and I can get the same thing.
Yeah, Hobby Lobby has them. Yeah.
I got my water barometer there. I like it. It's cool. You can actually tell what temperature is in the room just by looking at the thing.
Yeah, I got the Galileo thermometers.
Yeah,
I got one of those too. I've also got a Fitzroy storm indicator too.
Ooh,
These crystals inside this liquid will react a certain way depending on like the type of weather that's coming. And you can look at it and you can look at the chart and it'll tell you, whether it's going to be snow or, rain or whatever else. Pretty cool. Admiral Fitzroy.
Admiral.
Yeah, that's his little invention, the Admiral Fitzroy storm indicator.
Yeah, how do they navigate the oceans again? Do they use levels to do these things? They have to. They have to have a data to actually navigate around with.
Well, they use a form of trigonometry, which is three angles, triangle, straight lines.
Didn't level curve, Sam? That's what I heard earlier. Like sea level curves. That
better not.
Today. Yeah. Wesley said it actually. Somebody asked about curvature, and they said, "Well, sea level curves at a rate of what the 69 degrees per mile or whatever, or
1 degree per 69 miles."
Yeah.
I
know how they
that work out. Does that work out to like 8 inches per mile squared? About 7.9. Yeah.
Their maths are off, dude. They'll pick and choose with that. I've had Brenda do this several times.
God, Brenda, why are they so unbearable? Just even without the globe shit, just their personalities are just like unbearable. You know what I mean?
Yeah. Didn't Brenda try to come on one of our streams the other day? I can't remember who that was.
Yeah, it did.
It did. Yeah.
Yeah.
It wants to debate on everybody on every topic, like gender.
Oh my God.
Wanted to debate Derek on the idea that you can actually change your gender and like the amount of people who have and how they're almost suicidal after they actually went through the full process. Like they can't change what they just did, so they get really depressed and suicidal almost. I've seen it. They're like, that's not statistical, and yeah, they want to keep that agenda going so they can actually pervert society even more. Yeah.
It's almost like they got to always have a problem.
Yeah.
And there's a lot of people, they like to be a victim.
That's true.
That victim syndrome. They want to be a victim, and then they get attention that way. It's like, oh, look at me, I'm the center of attention. I'm going to dress up like a girl, and people laugh at me, and that's not fair. And it's like, dude.
You dressed up like a ghetto. It's not fair.
You asked for it.
When I was growing up, there was a show called MASH, and one of the characters on that was a guy trying to get out of the army by acting like a woman and putting on a dress.
You're talking about Klinger, sir, right?
Yeah,
that's right. Yeah,
he didn't want to go to war. He's trying to get out. That's the only reason he did it. He wasn't like he's trying
to get out of the army now.
Was it It was
trying to get a loony discharge. Trying to get a loony discharge. See,
MASH was the Korean War, wasn't it? Wasn't
yeah.
It was Korean. Yeah. But that was a good program. And you're right. Yeah, he did that to try and get out of the bloody war. Now people are trying to be like, he's doing that to look insane, and now people are being insane and doing that, and they want to be looked at as sane and normal, and we're all good and inclusive. Madness.
Oh my God. Trump was the military guy up here talking about what the mission was and everything in Venezuela and all that shit. And Trump's standing there and he's nodding out, falling asleep. I'm like, oh, come on, man. Listen, this can't last. This world can't last. Not at all. This has turned into such a clown show. I mean, even with this, I hear these people talking about globes and all this other, and I'm like, man, is your head really still in that school bullshit, man? Common sense ought to take over. It's like, well, you can see that this windmill is obscured by this, that, and the other. I said, yeah. And then common sense kicks in and you realize that water will not behave that way.
Right.
You know, so this is an optical, this is an optical effect. It's not a physical effect.
Oh.
I don't know. Anyway, I'm going to have to get off here. I got to go get to these dogs and I don't know what. All right, guys. Everybody blessings. We'll see you.
I suppose I better go off as well.
See ya, man.
I mean, the host gone. So
Later,
yeah, you could say bye too. I mean, Flats has still got to come and turn the stream off. So just whoever's left, if you want to chat, you can. But once he's gone, I think you can only chat a certain length of time, can't you?
Yeah, it's like I think it's like maybe an hour, and then it does.
Then StreamYard will kick you out. Yeah.
Well, I got things I got to take care of anyway, but I enjoyed today. It was actually kind of fun. I'm glad everybody came in. Yeah.
You did well, man. You did really good. I mean, like I say, I don't debate. I mean, my little observation was just my observation, but who am I to say that? Because I can't.
You notice how when he tried to hold me to the demonstration, like all of it, like the whole video, he like, well, I used that for a demonstration. It wasn't a citation. And he's like, well, fair enough. It's the only thing he can say, you know?
Well, that's it.
He had like a whole page of questions prepared to ask you. Like, seems like over half the time he was questioning everything. He had all the questions set up for you.
Yeah.
You know what I'm saying?
Yeah,
absolutely.
Yeah. Absolutely. Well, you notice how like in his little PowerPoint, he had Walmart with an asteroid hitting it. Yeah, they actually, it's a class thing with these people. They actually think they're higher class, and anything that they present is better than yours. It's like that kind of, it's what do you call that, posh, you know, or
but you
I would call it like
bougie where you're at instead of posh, bougie.
Bougie.
Well, what he was doing in the debate was like rhetoric, where he's questioning you and controlling the narrative, you know.
Or tried to.
It was supposed to be a list of questions like Flatzoid was asking, but he instead he gave you all the questions himself.
Yeah. But see, that's what their whole this heliocentric depends on. Circular reasoning, you know what I mean? Begging the question. It depends on that. It's you know, when you see it all the time. They'll give you an answer to something, and it's like, well, you try and get there. Well, where did that come from? And it comes full circle back to that, you know?
Yeah, and we didn't go to the scientific method. And actually, I was hoping that when we talked email to email, I said, well, you're gonna have to stick to the scientific method. But they never do. They never completely stick to the scientific method. Otherwise, their model doesn't work.
No, because they don't fully know what the scientific. They know what the scientific method is, but they add bits to it, like you get observational science. Well, no, not really.
No,
observational, just looking at something. How is that science? It's a first step, and in the scientific method. Yes, you've got to have an observation. Absolutely. But it's not science itself, you know.
Yeah, but in nature, there's too many different variables to like cling on to that one, you know, the gravity, because there's going to be so many different variables that you can't predict with.
Right. Absolutely. Yeah. Absolutely. Right, guys, I'm going to go. Chris, good seeing you. Ryan, good seeing you. Roger, bless you guys.
Yeah, good seeing you, PJ. You're doing a show later.
I'm on tomorrow afternoon. I'm not on tonight, guys. Yeah. So
I thought you were coming on tonight, and then I saw you change the time on it.
No, I was going to do it today, but I finished at 6 a.m. So by the time 2 came around, I was still tired, so I thought I don't usually go. I'm not meant to. Saturday's meant to be a day off. Saturday and Monday, isn't it? So like, I just thought I'll just do it on a Sunday because I'll be on twice tomorrow.
The weekend.
Yeah, I'm on twice on a Sunday anyway. You know what I mean?
Nice.
Sunday afternoon, then Sunday night. So I'll just do.
Yeah, I got chores to do around here. I got to go. I got to fit the radiator with a couple other things on my truck, and I got Rhonda's closet fell apart, so I got to rehang the
so
rack in it.
Fix the closet, not to go in it though. Not to go
No. But the thing is, she's got so many dresses. She hangs them all on one rack, and that rack can't hold the weight. I've even braced it up with extra supports, and it's already fell down again. So I told her, like, you can't hang that much on there. That's all there is to it. There's the sheetrock won't hold it.
She's funny. All right, guys. Bless you, and I'll see the guys in the chat at mine. Well, whoever comes to mine, because it's not all 51 comes to mine.
I'll be doing the stream later tonight. I'm just gonna. I want to recap a couple of things that happened in here. Just do, and I like I said, if you want to go look at what I actually have shown with all their quasi experiments, me and Ryan have been through the Cavendish several different times, haven't we? And there's so many different biases that go on in there. I don't know how they isolate them. A vacuum chamber will not isolate it. Groundings, the lead balls won't take all the electrostatics out of the experiment. There's no way there's not an environment you can do that. There's frictionless completely. Yeah.
So tomorrow I'm doing a testimony. It's a testimony one, from that Almost False channel, and it's to do with the LDS Church. So the secret rituals of the LDS Church, and it's a woman's testimony called Heidi Love. So I'm doing that one.
Did you see the comment? I think, are you tripping? Because I think of LSD when LDS.
Like, I see. Is that in the I think you put that in the vertical.
Yeah, I put it vertical. Yeah, I did.
Vertical, yeah.
That's the first thing I think of, but I know the acronym isn't exactly the same. But yeah,
I know, but it does. Yeah, when you hear LDS, you think of LSD.
They're tripping on LSD. They're out there having what they call when one of the elders die. They have those sleep. They like sleep on their actual graves.
Oh yeah, they go. It's called like something sponging or grave sponging. Grave soaking.
Grave soaking. What is that, man?
Well, it's when a member of their church, like just say Bethel Church, because it's them that do it, like Johnson's Church, Bill Johnson's church, right? If there was someone in that church that they thought had a good gifting from God, an amazing gifting from God, and when they die, they go and lay on their grave and soak their essence to try and get that gift. I mean, where in Bible is that? I mean, that's ridiculous.
Nowhere. If you lay there long enough, we'll bury you. You know.
Yeah, exactly. But they encourage things like that, and that's terrible. Weird, that's morbid. In fact, that's what you bloody call necromancy. That'd be part of necromancy. Yeah,
that's as close as you can get to it without actually performing some of those acts that
telling you. Me several acts.
I can't even picture it. Oh yeah, dude. Yeah, that's enough of that.
What do you mean? What necromancy? I wasn't talking about necromancy. I was talking about grave soaking, which would be classed as necromancy. I'm not talking about that intentionally. Roger asked. He asked what it was called because that's what that church does. They do grave soaking, which is not biblical.
Definitely not.
You what?
Sorry, Vicky. I won't ask any more questions.
Okay. All right. Say bye to everybody because I'm going. I'm leaving. Flats will have to come in to stop the stream. Right. I'm off, guys. Ryan. Love you guys. Chris, love yous. Roger, love yous. Love yous all.
If you guys want, you come over to the stream later. We'll have a nice little combo. I don't think you're going to be up at that late, are you?
Well, it depends if I wake up at that time. If I wake up, then,
I'll be on later.
Cool. But I've put my link in for tomorrow anyway. All right, guys. I don't know. May the pressure be with you.
Yeah. May the pressure be with you guys too. And everybody still listening to the stream? Are we still live?
Yeah, it's still live. It's still live. Okay. Flats will stop it. You know what? Any mods what? Can't hear you.
If any calls come in, ban them. Blame it on me. I don't care. I'm good.
Flats will probably come down to the toilet in 20 minutes and stop the stream or something anyway.
Oh, yeah.
Wesley unbans any of his little girlfriends. Ban them again.
Yeah, absolutely. But I don't think nobody's got to sit around and watch nobody.
Yeah.
I know, but that's because we're still here.
But wait a minute. People will watch hours and hours of people staring at a flower on a table, won't they?
Well, I've seen that. I have seen that. It's madness. It's madness. It's crazy. Remember when we was over in Rumble and we checked out this when I was live, and it was just a guy who went live every night, but all he did is have the camera pointed towards his iguana.
Oh yeah. They get thousands of views
all night. And you know that's not for the streaming sake. That's because Rumble pay you per video. So he's just doing long hours of streams of nothing
per video,
to try and get paid. You know what I mean? Stupid. If nobody's watching it, you ain't getting much pay for it. You know?
Just focus on a picture on the wall and just playing it for them.
Well, some do that. And the thing is, Rumble will let you off of that. Other channels won't. Like you used to be able to do sleeping streams, but now if you try and sleep on YouTube, a YouTube stream, YouTube will stop the stream. No, but if it's a sleeping stream, not if you fall asleep, if you're intentionally sleeping on stream and saying like, I don't know, if you gift or if you donate, it'll make a noise and wake me up, say that type of thing. You know?
Okay. Yeah.
Because they do that. They do things like that.
Anything to make content. That's not, I don't call that content, dude. I want to be honest.
Of course it's not. But then people will fall for it because they put a sign up on the wall saying, right, like just say it's TikTok and they do a sleeping stream or whatever. And somebody will put a sign on the wall, right, sleeping stream. If you donate or if you gift this certain amount, whatever, it'll make a loud noise and wake me up, or this music will play and I'll get up and start dancing, or you know. So people make content out of absolutely anything. It's not scary. There's this guy in TikTok as well. He used to be on YouTube, and he goes about stinking places up because he smells, and that's his content, and he loves it. He says he doesn't wipe, he doesn't wash, he drinks this certain pink juice, you know, and it's disgusting. It's disgusting. People are doing this.
It's shock value, I think. There, if you want to say anything.
Telling you. Right, guys, I'm off. Bless yous in the chat.
I'm gonna head out too, Chris. You by yourself? You'll be all right.
All right, man. No, I'm gonna head out. Yeah. You guys are gone. I gotta go because there's no conversation. So I'll see you later.
You talk to yourself, man, and to tell people you go to sleep.
Yeah. You do what you can do. Just put your camera on. Yeah. Go to the gym. Yeah. I can see your
30 second wake up timer.
Go to the gym. Go to the gym and start lifting, bro. You'll get a load of people.
Yeah. People.
Yeah, maybe.
Maybe
I'm still a little sore. I
would do that for content. If I didn't have the channel I did, if I went back to the gym, I'd do that for content. Just sit there lifting. That'd be cool. Because people make livings out of that. You know what I mean? Just showing you what they do in the gym. It's mad. But it's all steroid orientated now. It's all steroid orientated.
Yeah.
Anyway,
I never had a membership to a gym. I always had my own weights and systems that I worked out with.
Same as me.
Cheaper. You know? Think about paying a membership on a yearly basis. What you lose. Yeah.
Heaven says, I don't know why you say goodbye. I say hello. Hello.
Oh. You say goodbye and I say hello.
She's in Flats's chat.
Oh, she is. Yeah.
Right, guys. Bless you. Love you. I'm off.
All right.
All right. See you. See you guys.